Welcome all of you to the international seminar and welcome all exploring the world of health at this international seminar. So as we know, Geoscientists have a beauty unlike anything else. These gems have light in them. Their color speaks and say what words fail to speak. So we feel privileged that we are organizing a 3-day seminar come workshop on gemology. So now I would like to request all the dignitaries for having the plans and I request students to move. May I request our VC sir, Chairman of the Council, former Vice Chancellor of our University, Professor R.B. Karan sir, Professor at University Odisha, Professor B.U.T. Rai sir from Lucknow University, and the convener of this international seminar, Sri Nanda sir, former Deputy Director General Geoscientists and President of Institute for Now Odisha. Now I request Dr. Nanda, Head Geology and convener of this seminar, to join for the flash battery. Like to welcome all the respected dignitaries, kindly take their chair on the dais. I request to play the university anthem, and all members I request to kindly be standing for the respect of the university anthem. Now I request our students to offer some links to the guests on the dais. Thank you guys so much for being to the meeting. Now I introduce Dr. Asimamita Pradhan, the organizing secretary for this international seminar on workshop, to introduce about the seminar.
Very good morning to one and all. So respected Vice Chancellor sir, respected Madhumita Madam, former Vice Chancellor of this university, Chairman PG Council, Sabasatri Patnaik sir, Adhikaran sir, Jan Nanda sir, Vibhuti Rai sir, and convener of this program, Rajalind Madam. And I also thankful to all the members present of the from IQ, all other organizations like WCS, and all my dear students. So our department is a baby department, just born in 2018, and it is just 5 years old. And out of that 5 years, we have already exhausted a 2 year in COVID. So finally, I can say it is a 3-year-old department. So gemstone is a natural material, and it is having beauty, hardness, and finally reality. If there is reality, then only you can say it is a gemstone. And gemstone is widely used as a jewelry in India. So gemstone science is covering their identification as a natural or synthetic, and then it's parameters like colors, and there is the origin and geographic origin of the gems. So the authentication of the gem is as natural or synthetic depends mainly on the presence of minerals, fluid inclusions, growth, chemistry of the trace element, etc. So, in spite of negligible domestic production of gemstone in India, but India's revenue in gemstone is very high due to its use as a jewelry, and Indian gemological industry exports a lot of gemstones from outside India, and they cut, polish, and sell as jewelry. So this international seminar is generally we have planned so that the students as well as the research scholars throughout the state or the country, they can also have a wide whether it is original, duplicate, everything they can find out. So this is the theme of this seminar. Thank you.
Now I request Dr. Rosabita for the welcome address. Good morning for the all present over here. On behalf of Department of Geology, I am Dr. Visalinda, head and coordinator of this program and head of the Department of Geology at the University. And I have the honor and the privilege to extend a very warm welcome to all the distinguished dignitaries, resource persons, and our student participants and my dear colleagues to this 3 days enlightening international seminar and workshop on the exploring the world of Zen, Gemology, prospecting, and identification. This platform promises a captivating journey into the intricate region of precious stones, emerging geological insights with cutting-edge identification technique. The seminar intends to create an opportunity to know more about the geological setup and the source of precious and semi-precious stones of Odisha and Geology India. And along the integration of the exploration, identification, and treatment of some gem minerals. Over the coming days, we anticipate the mysteries behind the gem formation, discuss the innovative prospecting methods, and delve into the art and science of the gemstone identification. In the inaugural ceremony of this novel sharing platform, I welcome our chief guest and chief patron, Dr. Professor Santosh Kumar Tripathi, Honorable Vice Chancellor of Fakir University, Although he is a professor of PMIR, he is the man behind the dilemma of this program. I extend a hearty welcome to our guest of honor and Chairman, Chairman PG Council, Professor Sabyasachi Patnaik sir. I am honored to welcome our former Vice Chancellor, Professor Madhumita Das Madam, who is the founder of our Geology Department at Fakir University. I welcome you, ma'am. We are honored to have Professor James Sigley sir. James Sigley sir is a distinguished gemologist from the Gemological Institute of Africa with more than 40 years of expertise in gemological research. He is joining us virtually and he's a globally acclaimed geologist. I welcome Dr. R.V. Karan sir, former professor of geology at MS University, Baroda. He is a leading gemologist of international review. He is the author of very popular books, Gems and Gem Industries in India and Gemstone Enhancing TikTok Legend. We are pleased to have you here, sir. I would like to welcome Professor Vibhuti Raisa, a distinguished professor in the Department of Geology of University of Lucknow. We also serve as chairman of the Research Council and the idea of MBA Petroleum Technology and Management, including Gemology. He has a research specialization including Gemology, environmental geology, groundwater, applied geology, remote sensing, sedimentology, and he has completed 16 major research projects. Welcome you, sir. I will Dan Kumar Nandu sir, President IPO. He is the Deputy Director General of GSI and one of our well-wisher and partner organization of this seminar. I studied to welcome Ramadev Rudra, former Director GSI Kolkata, who is the key person of the WhatsApp. And since I am accomplished gemology in India, we have more than 25 years of experience in gem identification and application. I welcome Divya Banasar, Chief Technical Officer, Geoscientists, Dubai, and he has 20 years of experience in multi-technology exploration, including gemstones in diverse geological settings and mineralogical terrain in India and abroad. He is joining us virtually. I thoroughly welcome to Victor Jordan Practical Sir, a senior exploration geologist and has a range of experience from genetic to advanced exploration projects in several copper and gold mineral systems in Africa and Australia, and even exploration in Colombia, silver exploration in Madagascar, and ruby exploration in Mozambique. He is also joining us virtually. My hearty welcome to Mihir Kumar Chanapati sir, former Joint Director BGM, Government of Odisha. He has more than 35 years of experience and is a global mineral explorer with special interest in diamond and colored gemstone. He is also representing WCS, the World Consultancy Service, a sponsor of this event also. I also welcome Dr. Pranav Das sir. I welcome to Dr. Mohan Pradhan sir, Department of Physics, School of Applied Science, Teach. I welcome Mr. Prayal Kumar from James from Chennai. He is a gem trader and he is displaying also some gem ornaments here. I welcome J.K. Mohan sir, Honorable Dr. Jyoti James and Related Vocation. I welcome all the members of IGO to come and participate give their hands to organize this program. Thank you so much. Thank you, madam. Now I request Professor Chairman of the Council to address the gathering.
It was good. Most esteemed vice chancellor of those community party. Esteemed Professor Mohan. And all the dignitaries, head of the department, Geology, colleagues, students. First of all, it gives me immense pleasure that in the department of Geology of our university, not in one university, is organizing the seminar and workshop on sensors. Basically, the name is exploring on world of physics. So that's why I organized this Gen Science study. So as far as my knowledge is concerned, geology is the science of studying, plotting, and valuing research tools. So gemology is the science of dealing with natural, artificial gemstones. But the gemology is an identifying of gemstones. So gemologists are the experts in it. For example, like goldsmith and jewelers. But academically, somebody is having friends. So then only we can say that it's gemologist. So the career in gemology, have you looked at it in market or this career maybe because you know the case of the family jewelers. So that is also but gemology course by that course we can study about the quality of the find out the quality of students and the schools. So this particular gemology course, as it is a branch of mineralogy, which is exclusively concerned with identification. So I'm very much happy that the Department of Geology has taken up this type of workshop. So the so that we give also about their things. So each of the course, the student will be a wider protein. Also, in the academic open
Recording in progress.
In this pandemic.
What your teacher and what? When you replace her. So you join the command that community replacement of quality to address them.
Morning to all of you. Honorable Vice Chancellor for Chairman, City Council, Dr. Karan, and my distinguished audience here, and my colleagues from Geoscientists and from IBM, and dear students. We have come here. Now we are co-organizing from IBM Geology Department at the University, conducting this international seminar. As I heard, department Geology department is only 5 crore. And our association is also 5 crore. So now to 500 rupees for land to organize such an seminar. People think this is for always look at many people know the role of the geologist in prospecting and understanding the geology. Yeah. No idea for people know in terms of many people are mistaken. They identify a lot of money. Now I have our students who get learning something about gemstones from international experts or local scientists to our introduction to the seminar, and they will physically see the they will get an hands-on experience with agriculture and then we do a field work. And my opportunity to go to field to see that young whether to really are in field. Then what is the geological study? What are the in books? Then so I have this international seminar. Get opportunity to learn more about this and then propagate it. And if somebody is really involved, you can take a career out of it. And our being a representative of IGM, I organize officers of geoscientists of Geoscientists who are economic and professional experience. The youngest person in our is our so you can imagine we are a very old workforce, but everyone has an honest to share their experience. We can. I have no problem. It's an honest about many to share with from where they are. So the center to that is our model. And with that, we are going to provide help. So I have Thank you.
Sir, for your intelligent message, we are charged by your experience knowledge. Ladies and gentlemen, now we are rarely get actually chance to listen to these kind of personalities. Now it is an opportunity to welcome Institute Awards from great personality, Professor R.D. Kalan, sir.
So, take gemstones and extremely extensive models. But they were totally one of the difference. Where do these gemstones come? They are with Bible virtually. So I was going to predict from God.
Odisha, and that's where I like where they used to Andhra Pradesh, then it goes Tamil Nadu, then to Karnataka, then Kerala. So all these areas it becomes that becomes a tribal belt. And who exploits these resources? The merchants from various parts of India, they come to this place of diversion. Cost it to pick up certain people. And you this labor charge and go make that money. Then what happens to the drivers? Who own all these things? We are being neglected. Now, my aim today is to see that the real owners of these were had been benefited for rich and to things. To see that these people are being benefited from their own wealth. Then comes study of gemstones. Study of gemstones is not gemology. It's not even much importance in India. Our research in gemology ends up being never class specialty in India. We respect only these nine stones and don't bother about other stones. There are many hundreds of beautiful gemstones which most people have not heard about in India. So you can see that all these things are being studied systematically. And these gemstones will have to be respected and known. So we earn a lot of money all over the world by cutting and polishing here and selling them all of this. So we have to study gemology very seriously. And further, we have to adorn them. So with this thought, I take to the end of my lecture. Thank you, sir. So let us have the privilege of listening to the lecture of Professor Vibhuti Rai, sir. May I now this Professor Vibhuti Rai start with? Good morning, all, and good evening to Dr. Chamberlain, who has joined us. Then, of course, to the right of God. First of all, I was so my gratitude to this university, very renowned university. For that, I thank Professor Jane Das sitting across the table, and Ramana Vinoya, and many distinguished guests and students. The next generation here. The topic which we are deliberating for the next 3 days, that's mainly the aspect of gemstones and its occurrence across the country and across the world. How this gemstone is going to bring change in the economic work of the country, as perhaps all of you must be aware that India's highest amount of foreign exchange is earned through gems in polishing the gems, especially diamonds, from all over the world. It is one of the leaders, and it's not a leader today. India has been a leader for the last almost 5,000 years. In 2,000 years in particular, then to the rest of the world, the gems were supplied from India. As a matter of fact, the first diamonds were discovered in India, and the world's 10 most expensive and most beautiful diamonds, out of those 10, 9 were discovered from the southern India, from near Telangana, and including Mohan. So the historians did not mention much about the Indian gemstones. And when I did research, I realized that
traveling as a British traveler who came here in the 17th century. He mentions in his memoir that he has seen in Golconda, which was the selling mandi for diamonds, 41 Ladia loads, like 41 of them being sold every day. So you can imagine the level of gemstones that were being found and being sold for the rest of the world. Britishers, they wrongly mentioned that India used to be that's wrong. ये हीरे का शेयर हुआ करता. As a matter of fact, you would be surprised to understand that historians say that from Europe they used to come to India to take spices. Now anyone can guess why they would eat spices when it is not staple food in their regular food habits. They do not have enzymes to digest those spices. They were not taking the spices from India. They were taking the diamonds, the emeralds, the rubies from India. So when you do research, you get to know these kinds of things. आप सभी imagine कर सकते हैं कि जब let's say any spice which we do not eat coming from South America, why will we eat? Why will we import it? No, we will not. So they were actually taking shiploads of gemstones from India in the guise of spices. So this is a topic on which we are sitting in this beautiful campus. I must congratulate Honorable Vice Chancellor sir, to make this the Green campus such a wonderful place. I'm thankful for me and opportunity to come all the way from Lucknow, and I am enjoying every minute over here. Wonderful weather for me too. It's actually warmer for me, and that's why I'm not wearing a coat today. But I must thank the organizers, Madam Rosalinda, and others, and who actually first informed me about this, and to all the organizing team who have been doing wonderful work here. I hope after the deliberations, the gemstone would go down the spine of every student here, because all of you are gems. Thank you very much.
Thank you. Thank you, sir, for your great message of wisdom. May I now request Professor Madhumita Das Madam to address the public? Namaskar. A very good morning to all. Esteemed Vice Chancellor, Professor Tripathi, all the dignitaries on the dais, Professor Sikri, and all the members of IGO. And it's a pleasure to see my classmate Mihir Kumar Senapati also here, all the faculty members and my dear students. I'm extremely happy at the same time. I am feeling very nostalgic because first to 5th March 1994, 30 years before, I was organizing such a orientation course in Gemology in the Department of Geology, Uttar University. It was organized by Geological Society of India, Bangalore, and the person, Professor R. D. Charan, was the convener. So after 30 years, I am having the same platform, and it gives me really immense pleasure. And then the Vice Chancellor was Professor S. Acharya, and all the certificates were signed by participation certificates were signed by Dr. B.P. Radhakrishnan, then the Director of Geological Society of India. So after 30 years, I again attending a Gemological event, and I'm extremely happy because it is being happening in Fakir University. And the geology, I think I didn't know, very close to my heart. That geological orientation course, this is mainly I am telling something for my students who are the future geologists There are many misconceptions because common people or laymen they think that the every signing gem is real, but it's not so. All the blues are not enough, all the yellows are not Pukhraj. For that, also we have heard a story that the Mughal Emperor Shah Jahan had a big ruby throughout his life, and afterwards we came to know that it is just a variety of spinach. It was not a ruby. So it is the I think the duty of a gemologist or a geologist to identify the gems properly. So that is why this sort of orientation course workshops are necessary to train our youngsters. And another common ideas are we know that a huge store means the cost will be higher. But usually, all the precious gems are small in size. That is another conception. And like minerals, gems are also very, it takes a long time to form. That means they are finite resources. And I think almost 3 billion years old gems are also available. So from that point of view also, we have to, when we go for jets also, we have to be very, very careful about it. And for the young researchers and for the young students, there is huge scope for gem hunting and it can have two approaches. When we have stalwarts, all the research persons who will be talking to you in detail, we can have either a structural approach or a geochemical approach. Because Odisha has great potential for gemstones. So structural approach, I think all the IGO members will discuss. Wherever you come across with tear force associated with some upward thrusting, it's a potential zone for gemstones. Geochemical approach, the faculty members should go for testing sediments or spring beds, I would suggest. Because any anomaly in sodium content will hint about the occurrences of gems. In also in Colombia, South Africa, South America, the high sodium indicates and high sodium also which is depleted in lithium, potassium, molybdenum, beryllium is an indicator of emerald deposits. The students can go for that. Another new instrument that is very commonly used is berilometers, which is very helpful for identifying the emerald, which is a very light instrument and also it is portable. So this machine, this berilometer is antimony sourced with gamma radiation. And another, I think, possibility is we can go for like they have found black cells in Canada. We can also explore the black cells of Odisha. And also, as we know, we are in the Eastern Ghats and we have huge pegmatite deposits. But the pegmatites are useful geochemical signatures provided they have a fraction, they must be fractionated with, we have to look for the ratio of potassium rubidium and rubidium strontium. Then we can go for the pegmatites and to identify the buried plutons, we can take help of, we have resource persons who are expert in satellite imagery, though we can also go for that. So I have two ways. You can say I have two dreams regarding gemstones. We know that has identified the rarest among rare is much graphite, the rarest gemstone in the world, and which has hardness 8.5. It's a beryllium aluminum oxide. So I think in Odisha, at least in India, we must find much graphite. And another thing, the most expensive gem is the blue diamond. So when we have at Sinapoli Blood Nuapara district, diamond means the numbers have been discovered, they have been tested in the DG, we have a diamond lab. So why not we expect the most expensive gem, blue diamond in Odisha? I think we will get it definitely if we explore it properly. And the blue diamond, the first result sold recently in Hong Kong, 1 carat is $3.93 million. So I would request Minister Sanam to find the blue diamond in Odisha, at least in India. So there is a huge challenge before the Department of Geology, Fakir University. I request the Vice Chancellor, who has already a soft corner for the department, please provide them not much, one gemological microscope, one spectrometer, one spectroscope, and the department will be carrying out all gems, research on gems in next 5 years with handholding of IGO. Thank you so much. And I wish a great success to this event. Thank you. Thank you, ma'am. I must say that you are also close to our heart, and that was really an inspirational message for us. So now we have another one, virtually, Professor James Sigley, who is from Geological Institute of America. Now I request Professor Sigley to say a few words for our audience. Am I audible, sir? Sigley, sir, am I audible to you?
Are you talking to me?
Yes, sir.
Sorry. Did you want a brief introduction?
Yes, sir, we need a brief introduction for our audience now.
I'd like to thank the organizers of this conference for the opportunity to participate today. My name is James Shigley. I'm a research fellow at the Gemological Institute of America. I joined GIA in 1982 after studying geology in college. GIA is an educational and research institute that serves the jewelry industry and the public with information on gems. The institute was founded in 1931 in Southern California, and we have been teaching gemology for over 90 years. We have a school in California and New York, and also in 6 overseas locations, including a GI school in Mumbai. And we estimate that we have trained over 250,000 students over those 90-some years. We also developed the diamond grading system for polished diamonds, and that system is now used around the world. And we've issued a vast number of diamond grading reports on I think all the most important diamonds. And what I was going to talk today when I start is to give you a little view of gemological research at GIA, but we have a unique opportunity to do some science on gemstones. That's the introduction.
Geology. So now it's time to inaugurate our discovery. May I request our students?
हाँ
Okay, now this is our answer to the carbohydrate. What is the again? And here our answer to Professor R.D. Karan sir. Next, I tell you to Professor E.P. Rai sir. And who is another geology from the Department of University Professor Mohan last madam having the license to study geology. I request to present the limited gentleman. Chairman, Professor Publishing Consignment. I like to present something connected digitally routine of the life. Dr. Kamalendra Raya madam. Dr. Mohit Sevagar sir. With the concept for international community of water. State reference from Bhubaneswar.
सार के
Professor Kamal, Professor Pradhan Kumar Nanda, Professor Siglet, Professor Geology Baran, Madam Vanoda Indra, Mr. Nanda sir, Jayan Das, Pranam and Dimitri Andana. I am actually
हिमाचल जमुना गंगा उच्छल जलधि तरंगा तब शुभ नामे चले तब शुभ आशीष मांगे गाए तब जय गाता जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 जय
Very happy that explain the options in the international seminar by the Department of Geology. I will consider Department of Geology as the chairman of the Geology. Therefore, I always try to observe them. Whatever they suggest, I answer. Whatever they propose, I answer. But I propose from some laboratory which are not been proposed by the James are backward actually. So in the backward mentality, they are working, they are thinking, they are actually goals. As they know, they are right stones. But here, each right stones are somehow covered with words, I think. One day they are not coming up. My suggestion would be please remove that point in your mind, come up with proposals, and then implement. There should be no limitation at all. I've already suggested the scientists, the father James from Odisha, that they should support the department. They should come up with the proposal of new proposal of a new lab. So if the submitted, we'll also get it to the department. In 3 months, Department of Geology is spread to another thing. So then it takes large hall where you can establish your laboratory. Then what difficulty at all. You will be having a laboratory of this. And regarding this seminar, I have not completed the now. Not a technical person, but I have. Therefore, when proposal came to me that this seminar workshop to be conducted, I blindly said yes. And whatever we find, whatever to conduct, very thankful. Again, I am addressing the James from the side that they have supported us. I hope that support will continue in future. From Sir Karan's support, he has already assured me last time that he will support us in establishing a museum. And I beg before you, sir, if you can support us, we are ready as the best university, best department in among the university. So that support I expect in the country. As told by you last evening that it is found in tribal areas, let us have a movement started from this year. I am in charge of Central Maharaja Central University Barikuna. I explore any support required to explore the area of Sanskrit and other areas. We will extend that and we will go ahead with that movement. I'm very happy that this process is not limited to the four walls of this hall. Our day is exclusively HIPS patterns. It's very essential for the students as well as researchers. I think students, if you don't do the IT of students with the help of the scientists. And I hope all success of this seminar. Thank you very much. We should not make the professors if you're waiting for us, that will allow his space to be there. Thank you very much.
So much for being with us yesterday I was managing because I love you and support that people but all the time. Thank you, sir. So may I request persons to join with my number side to felicitate our consent.
I have to go with the judge.
Thank you, sir. So I will be a little late for time. I thank all the students in our small program for. I thank all the invited guests and the faculty members and students. So now we straightly go to listen investigation virtually. So I request all the members present on the next stage. And, now request investigation to strategy talk for our audience. Speakers, am I audible to you?
You can start.
Am I audible to you, speakers?
Dr. Shigle, can you hear me?
All set?
We are sorry for little delay and we'll be starting your lecture. You can go ahead the presentation of your lecture, sir.
So would you like to begin now?
Yes, sir. Yes.
Okay.
Okay. The meeting, formal meeting is over now. It is now technical session. The first lecture is by you. Please begin your lecture, sir.
I'd like to thank you for this opportunity. I'm here to talk to you about gemology as an evolving science. I thought what I would do today that might be most helpful is not so much to talk about the types of projects we're working on, but I thought I would focus on more how we do gemological research, how we do studies of gems at GIA. Now, at the end of the talk, you may have some questions, and I don't know if I will have a chance here online to answer them, but if you put any questions to me in writing, email them to me, I'd be glad to answer you in writing. So again, I'm going to try to give you an idea of how we do gemological research at GIA, the techniques we use, and the techniques that we're looking at now and in the future. So gemology is an evolving science, the world of gemology. And I've tried to list some of the ways of that evolution. We have new locality sources of natural gems. There's a wide availability of synthetic and treated gem materials in the market. Standard gem testing with gemological equipment can be challenging, and there's an increasing reliance on gem identification reports. And there's certainly in the laboratory a growing importance of the use of scientific instrumentation for studying gems. There's also a lot of development of gem testing instruments for use by jewelers. And we, of course, have the internet and social media as information sources. Now, if you joined GIA with me in 1982, GI would look very much the same in some ways. We were teaching gemology, but in a research sense, it was very different at that time. We had very limited scientific instrumentation available to us or to anyone else. There were no personal computers, there was no cell phones or email, no internet or social media. Any results we obtained were in the form of paper documents, and we had no searchable information database. Now, of course, 40 some years later, in research, we have an extensive use of analytical instruments. We have scientists and technicians. We have data collection and analysis procedures. We've developed a searchable information database, and we are trying to share our results through publications and presentations as often as possible. I just tried to list here kind of the main areas of research that's going on at GIA. We're looking at all types of gems, diamonds, colored stones, and pearls. And the challenge is identifying those that are natural, those that are grown by a synthesis process, and those that are treated. We're interested in understanding the environments of natural gem formation. We're going to the field to collect colored stones at gem localities. Country of origin determination for colored stones is an important activity for our lab and other labs. We're interested in understanding the cause of color and optical phenomena in gems, and we're involved in the understanding how the cut affects the visual appearance, and finally, testing instrument development. Those are kind of the main areas of research going on at GIA. Since 1934, we have published a professional journal, Gems and Gemology. This is a subscription publication. It comes out 4 times a year. But I wanted to inform your students that if you go to the GIA website, all the issues of our journal from 1934 until just the most recent can be viewed and read and downloaded at no cost. So you can read exactly what we are doing today by going to our website. This idea of an information database is so important. Research on gems requires access to information on the types of gems that you are investigating. And by information, I mean observations, gemological properties, spectroscopy and chemical analysis data, photographs, and other information. That's what I mean by a database. There's certainly a lot of published data on gems, but it's widely scattered in the literature. That may be difficult to access, and it may or may not be very useful to the problem that you're dealing with. So we, oftentimes researchers in the gemology field, have to create your own searchable database using your own instrumentation, and whenever possible, obtaining data from gem samples of known origin, that is a known natural occurrence, a known synthesis method, or a known treatment method. These are just kind of the basic crustal environments of gem formation. We have on the left a sapphire and a basalt, which is a magmatic rock. In the center, an emerald and calcite in a hydrothermal vein. In the right, a ruby in a metamorphic rock. And of course, there are a few gems like opal that form in a sedimentary environment. But these primary gem host rocks can weather over a geologic time, and they release gems into the environment, and they can become concentrated in secondary alluvial deposits. And it's the chemical elements in gem minerals, they arise from these geologic environments of formation. Over the past 15 years, we have been going to faraway places to collect rough gems, colored gems in the field, because that provides us information on the local geology, the geographic location coordinates, the sample acquisition conditions. Did we collect the sample ourselves, for example, as well as photographs and video footage that we can use in our educational materials. And since 2008, we've had about 95 expeditions to 21 countries. And we've had now a collection of some 22,000 rough gem samples that are available to us for research. And the photo in the center is just a view in Ethiopia. And I don't know how well you can see it, but there's kind of a dry river channel in the right center, and people are digging sapphires along that river channel. In the colored stone market, there is an importance placed on the country of origin of colored stones, such as, in particular, ruby, sapphire, and emerald. And here I showed us 3 examples of very high quality blue sapphires from different localities. And despite their similar appearance, in the market today, these sapphires would be valued differently because of their geographic origin. Of course, we were not present when these original rough crystals were found, but we're asked, we and other laboratories are oftentimes asked, to give a country of origin report. This report is an expert opinion on the basis of the researchers and the gemologists, based on the gemological features of the gemstone that we're examining. And these gemological features, again, depend on the conditions and environments of gem formation. This is the standard gemological testing equipment that gemologists typically use today: microscope, refractometer, ultraviolet lamp, fluoroscope, dichroscope, spectroscope, a balance, and a leverage gauge for measuring proportions. This is what gemological training GI educates our students to use. But we're now increasingly involved in the using scientific instrumentation, and there are really 3 areas that we focus on for characterizing gems: microscopy, chemical analysis, and spectroscopy. But when you're anticipating or thinking about acquiring a piece of scientific instrumentation to study gems, you have to keep a couple of things in mind. For the most part, you have to be analyzing gems non-destructively. You can't alter the color, you can't cut the gem in half, for example. So it has to be, for the most part, non-destructive analysis, because these gems can be very, very valuable. Scientific instrumentation has a significant purchase price and an annual service cost, a contract cost. You need for trained operators and data analysts. You need a kind of a standard data collection and analysis procedure. That's so you can compare the data collected on many different gem samples. You also have to kind of periodically calibrate your instrument to ensure it's operating correctly. And you have to fit the gemstone in the instrument to analyze it. So you may have to modify the sample chamber to hold the gem sample, which could be a gemstone. It could be a gem mounted in a piece of jewelry. It could be a mineral specimen, a crystal, or it could be a carving. You cannot alter the gems to study them unless you own them. And then, of course, you can do what you like. So we're going to start with microscopy. This is probably the most important tool for gemologists. And we, and I'm sure you there, are oftentimes teaching gemology with photographs. So we have a couple of microscopes and we are taking pictures of features in gemstones. I have this picture of this book on the top right. It's by the famous Swiss gemologist Edward Gubelin and my colleague John Cuevla at GIA. And this is kind of a photo atlas of inclusions, and it's kind of a reference book. And it is kind of a picture of a fluid inclusion in a barrel with transmitted polarized light, so you get a lot of different colors, but you see all the different phases in the fluid inclusion. Well, we're photographing inclusions in gems. because they are direct evidence of the geologic environment of formation. So just a couple of examples, Cambodian sapphire with a pyrochlore inclusion, a Colombian emerald with a multi-phase inclusion, and a Mozambique ruby with some sulfide mineral inclusions. These inclusions are trapped from the surrounding environment and are important for gem identification and color origin, country of origin determination. Chemistry is the next real area of research effort. And I just show here, this is just a graph of the important 10 elements that make up about 99.8% of the Earth's crust. Obviously, titanium and iron are in those top 10. But other elements, chromium, vanadium, cobalt, copper, nickel, zinc, manganese, are important coloring agents in gems. And then we also find some rare elements, lithium, beryllium, and so on. These are the type of gems that we are analyzing for in the gem samples that we are working on. So in doing a chemical analysis of gems, there are a couple of questions that you kind of have to keep in mind. Is this a qualitative chemical analysis or a quantitative analysis? Qualitative, what elements are present? Quantitative, what elements are present and their concentrations? Is this a volume or a spot analysis? Do you need some sample preparation to do the analysis? And is there any potential sample damage, especially on a cut stone? Now, I just kind of use blue sapphire as an example here. In a gemstone, there are major, minor, and trace elements. In this case, the major elements are aluminum and oxygen. Minor elements from about 0.01 to 1%, in this case, titanium and iron, and below about 0.01% roughly, gallium, chromium, vanadium, silicon, others. These minor and trace elements substitute for the major elements in the crystal structure, but they're oftentimes unevenly distributed in the material. And this kind of is important because if you're doing a spot analysis, it's rather difficult to make sure you're analyzing the right location to make the chemical analysis. And again, this minor and trace element chemistry is very important for gem identification and for country of origin reporting. Historically, mineral analyses would be reported in percent, and typically a percent is an oxide, percent iron oxide or percent magnesium oxide. But today, we oftentimes use a unit called parts per million. And I just wanted to relate what a parts per million is to a percent. So just 1% is about 10,000 parts per million. 0.01% is 100 parts per million. This is the range of where trace elements and minor elements, the ones we're analyzing for, occur. And even today, we're kind of chasing after increasingly even smaller concentrations of parts per billion and maybe eventually parts per trillion. This is the world of gem testing in terms of chemistry. If you're going to do a quantitative analysis and determine how much of the elements are present, you need to analyze a standard material of known origin, of known composition. So most of our analytical work on colored stones is on ruby and sapphire. So we have developed a set of synthetic and natural corundum samples for use as standards for the analysis of these important two stones. And by standard, I mean it contains elements of interest at known concentrations. So we analyze the gemstone and we analyze the standard. We know how much is present in the standard, and we can calculate how much of present of the minor elements are in the gemstone. So we had a synthetic corundum crystal produced for us, doped with elements of interest at known concentration levels. And it was very evenly distributed. That was the criteria. And then we would slice up this crystal, and we would use this and our other standards to all our laboratory locations which are involved in this type of research. We all have the same standards. This is vitally important if you're going to do quantitative chemistry for gemstones, to have standards where you know the concentrations that you're concerned with. There's two real techniques that we use for chemistry analysis. The first is called X-ray fluorescence, or XRF. It's a rapid qualitative volume analysis. You have a beam of incident X-rays from the instrument that eject electrons out of the atoms. And then you get a higher level electron dropping down and emitting X-rays as fluorescence. And those X-rays are characteristic of the chemical elements in the material. So the graph at the bottom is just on our monitor, on our screen at the instrument, and you see these light blue. These are peaks. So the peaks are at particular energies, which are characteristic of the major, minor, and trace elements in the material. And the intensities, the heights of the peaks, are somewhat related to concentration. But this offers a quick, non-destructive, all you need is a polished flat surface to get a quick idea of the color-causing trace elements that are present in many colored stones. And this is a tourmaline. It's one of these copper tourmalines. It's got manganese, copper, and gallium peaks. But this is kind of where we start in terms of doing a chemical analysis. The more detailed method is called laser ablation mass spectrometry. So in the photo at the top right, the gray box on the right is the laser unit, and the white box on the left is the mass spectrometer. So what you're going to do is you're going to orient the stone, and you're going to analyze along the girdle surface. And the picture on the lower right shows the very tiny 50 micron spots. And we normally analyze several locations around the girdle of the stone, trying to pick areas where there's no color zoning in the sapphire or no prominent inclusions. So when the laser fires, it removes small particles of material, and those are carried by means of a flowing gas into a high temperature plasma. And all the atoms in the material are ionized, and you can detect them with the instrument. So the graph on the bottom left is what the operator is looking at when he has the instrument running. So from about 10 to 40 seconds, time is on the bottom axis. From about 10 to 40 seconds, you're going to be collecting a background signal. No laser's not on. When the background is done, you turn the laser on at about 45 seconds, I guess, there, and you see all the graphs jump up. You're going to let that burn through the outer surface of the material for a moment, and then you've got about 30 seconds of data collection. And you can detect all the elements, the naturally occurring elements, down to parts per million range, quantitative analysis. You don't need any sample preparation, but you do produce some minor surface damage. But of course, that can be repolished without too much difficulty. And what you end up with from that type of procedure is a plot, such as this one, which is vanadium on the horizontal axis and gallium on the vertical axis. And this, again, are data points in terms of parts per million. And what you're trying to do is compare your unknown, which is the black circle with the red edge, against known samples, which are shown in the various colors, known other rubies in this case from other countries, and you're comparing your unknown stone from your client. And it'd be nice if the data points kind of plotted in different areas of this graph. But you see, there's oftentimes kind of a frequent overlap of data. How do we address that? Well, there are a couple things we can do. Maybe we can pick different pairs of elements, or we can graph elements 3 at a time on a triangular plot. But there are a lot of these graphs that are produced looking for hopefully a kind of a clear indication of this unknown ruby, where it comes from, compared to rubies of known origin we've also analyzed that are in our database. Well, it gets even more complicated, and this is blue sapphires, similar kind of plot in terms of iron and magnesium and titanium parts per million. It's chaos. It's total overlap. Because why is that? Well, the geology of the gem deposits in various countries is similar. So the trace elements that end up in this case, the sapphire, are similar. Well, we're doing a couple things to try to address this, and one of them is data filtering. So on the left, this is again blue sapphire analyses in terms of gallium and magnesium on the horizontal two-dimensional graph, and vanadium on the vertical axis. And the unknown, we know where it is because we just analyzed it. It's in that mass of colored data points in the left-hand graph. So one technique we're using is to filter out excess data points that are far removed from the location of the unknown. And when we do that, we strip out all this excess data points, which are far away chemically. And this, now you end up getting a much simpler plot on the right-hand side and a much more likely chance of kind of saying, you know, this case, this blue sapphire is from Sri Lanka in terms of chemistry. We're also been experimenting with more multidimensional modern mathematical techniques to kind of plot data and analyze data. So this is just kind of a data set on the left-hand side, a number of samples listed in the right-hand column, and then A, B, C, and D are just any elements. And if you just look at this set of numbers, it's very hard to see any pattern. But what we're trying to use is modern statistical methods, in this case, what's called principal components, but there are other methods, maybe even artificial intelligence, to help us understand how we can address this problem of chemistry and chemical analysis of gems. And now I'd like to talk for a few minutes about color and spectroscopy. Color of any object, any transparent gemstone, arises from 3 causes. You have the emission spectrum of the light source on the left. You've got the absorption spectrum of the material in the center, and you've got the color sensitivity of the human eye. So you have these 3 components, the illuminate, the object, and the observer. And if you change any one of them, the color will change. Now, obviously, if you switch gemstones, the absorption spectrum will change and the color changes. But if you change the source of illumination, you produce what in some gemstones is called the Alexandrite effect, where the gemstone has one color in daylight and another color in incandescent light or artificial light, and it's because the emission of the light source is changing. So we spent a lot of time looking at the spectra of gems, and you are familiar with the light spectrum there at the top, with energy increasing toward the violet end of the spectrum and wavelength increasing toward the red end of the spectrum. Most gems are colored by what's called selective absorption. So on the bottom, I have one of these absorption graphs with absorption going upwards, shown on the left-hand side, and transmission increasing downwards. And I show the visible spectrum from about 400 to 700 nanometers, and from about 400 to 650 roughly, or 600, the light is being absorbed as it passes through the gemstone. What is being transmitted is the red colors, and that's what your eye sees, is the pinkish red color of this diamond. It's the idea that the color in most gems is the result of selective absorption or selective transmission of light as the light passes through the gem material. Well, the path length through the gemstone is important. So if you have a greater thickness of material, you have greater absorption and a darker color. Now, if gemstones were flat discs, such as these pieces of plastic on the left-hand side, spectroscopy would be very easy. You have a known path length. You just measure the thickness of this flat disc, and you can directly measure the absorption. But in gemstones, and this is just a model of light going through a diamond, within gemstones, the light oftentimes bounces more than once. And in case of diamonds, it could be many times. So we do not really know the path length. And so we don't have a direct way of measuring the absorption of light passing through gemstones. And that means a lot of the absorption graphs have no scale on the vertical absorption axis. Well, spectroscopy has been used for a long time at GIA. These are some of our early leaders using a spectroscope in the 1930s and 40s. And what we're looking at in spectra, they provide evidence of optical defects in the atomic structure which cause color. So this is kind of a couple of examples on the left. This is a kind of a two-dimensional representation of the carbon atom arrangement in diamonds. And when you have nitrogen symbolized by the N and a vacancy, which is a missing carbon atom, when you have that type of defect, the diamond will take on a yellow color. Whereas if that defect were absent, it would be colorless. In a similar way, if you have chromium substituting for a few of the aluminum atoms, that causes ruby to have a red color. So it's these optical defects that produces selective absorption or emission of light. This is my colleague Bob Crowninshield, who was one of the leading gemologists in the world in his day. And in the 1960s, he began really championing the use of the spectroscope for gem identification. And at that time, he produced a whole series of drawings using pencils and maybe some other types of drawing tools to create some drawings of the visible spectrum pattern of all types of gemstones. And we have these patterns in our gemological books today. And I just show you a couple of examples at the bottom, a couple of colored stones, ruby, zircon, and so on. You see the color spectrum, you see 400 to 700 nanometers, and you see a pattern of dark bands. The dark bands are the regions of the spectrum that the gemstone is absorbing. So you have white light coming through, and part of that spectrum is absorbed. You're going to be sharp bands or broad bands. And of course, because you have the wavelength scale, you can, of course, kind of get a pretty good idea where the bands are located, the nanometer positions. But I think most gemologists really are just oftentimes just looking at the pattern of the dark bands, because that's an immediate indication of many cases what the colored stone is. So again, selective absorption, visible spectra, and color. So here's a yellow diamond. Here's my diagram of the yellow diamond, white light entering the diamond, and it has all the colors of the spectrum. And because of the optical defects related to nitrogen, the diamond is absorbing the blue and the violet, mainly those parts of the spectrum, and it transmitting or emitting the other parts which recombine to give the yellow color appearance. So this is how on the top left, that same graph that you see in the spectroscope with the dark bands toward the blue end of the spectrum. And right beneath it is the absorption graph, which we would record. And again, absorption is going upward with no scale because we cannot tell the path length, but we can tell the nanometer positions quite accurately. And you can see the peaks on the graph correspond to the dark bands in the spectroscope. So we use an instrument called a spectrophotometer to record spectra. And we do that because we can look at a wider wavelength range than the visible spectrum because of the detector. So you can look out oftentimes into the ultraviolet or the infrared. We can also detect with the detector very weak spectral features that would be difficult for you to see with your eye in the spectroscope. And we can get an accurate, very accurate determination of the nanometer, the peak positions. So a spectrophotometer, if it's a transparent material, this is kind of an absorption transmission spectra. Or if it's an opaque material like a pearl, you can do a reflectance spectrum. But this is the cause of color, and it's important for gem identification. And just again, it's a typical example of sapphire, blue sapphires. Most sapphires either come from a metamorphic rock or a magmatic igneous rock. And you have a spectrum pattern. You can see the spectrum goes way beyond out into the infrared and down into the near ultraviolet. But it's these absorption features, and we pay a lot of attention to these absorption features because they're what's causing the color. You probably are also familiar with polarized light and polarizing filters. Light normally is vibrating in many directions in an orientation that's perpendicular to the direction that the light is traveling. But when it passes through a polarizing filter, the light is constrained to vibrate in one plane. If you have two polarizing filters and they're aligned in the same direction, they will transmit the light. But if you rotate them 90 degrees to one another, the two filters, they will not transmit any light. So polarizer converts unpolarized to linearly polarized light. And a dichroscope, which is what's, I don't have a picture, but a polariscope, a dichroscope's there on the left. This is what is used to separate isotropic gems, things like diamond, garnet, spinel, things that are isotropic from anisotropic gems, which break light apart and have different refractive indices. So this is a simple example of a tourmaline, which is a uniaxial, one optic axis, two refractive indices. One is along the long direction of the crystal and one is perpendicular to that direction. So if you put some tourmaline crystals and put a polarizing filter over them and you rotate them, you will see the pleochroic colors. So you want to kind of, in an ideal sense, collect these two colors because you have two spectra to really understand the cause of color. And this is a more complicated but important mineral called tanzanite. It's optically biaxial. It's got two optic axes. Here you're going to have plates, ideally, so you have the two of the refractive indices in one plate. But you see that pair there, photos at the bottom, just by rotating the polarizing filter, the profound change in coloration that this mineral has. So we have a little device that we built for optically orienting rough gem material. So we attach it to a post, and you can put that post in this device, and you have the optics that allow you to orient this little crystal optically. And then you can take it out of this instrument, still in the holder, and you can put that into a saw and saw parallel to the directions you want. And you can produce, either by sawing or polishing, a more of a flat plate or something with roughly parallel sides. So I show a zircon there on the right-hand side. And again, when you record the spectrum and the two orientations, you see the two spectrum parallel and perpendicular to the optic axis, and you see the blue and the gray colors. You have to have oriented samples and polarized light to really understand cause of color in gemstones. We also use infrared spectroscopy, which is very valuable for detecting type diamond, type 1 or type 2 diamond, and nitrogen content. But we can also detect molecules vibrating in the gem material. So at the top, this is just a jade, and it's got some polymer and wax absorption features. Those are materials that are used to put into the jade to kind of make it look better appearance. At the bottom is an emerald. Natural emeralds oftentimes have water, and there are a couple of water absorption peaks, and also some peaks due to oil or resin, which are oftentimes put in emeralds to kind of hide the visibility of the fractures. We can also do luminescence spectroscopy to understand the fluorescence. So colorless light yellow diamonds often have blue fluorescence. So on the left, you can operate this in two ways. You can fix the excitation, which in this case is at 365 nanometers. That peak that goes off the graph, that's the long wave UV wavelength. And then between 400 and 500, you see this broad peak. That is the emission of blue light excited by that 365 nanometer UV incident light. But you can also kind of switch this around. You can also, in this case, fix the emission, which here is going to be at 440 nanometers, which is the high point of the fluorescence. And you can scan the excitation, and you can see exactly what wavelengths in the UV range are exciting that fluorescence. So this allows us to kind of better understand fluorescence in all types of gem materials by this method. Laser Raman spectroscopy is a really important technique. You have a laser that's aligned along the optics of a microscope. It is a very rapid method of doing mineral identification. And just as an example, I show a group of red stones. It just takes a few minutes to record a Raman spectrum. I've even seen at the mineral shows, we have a big one coming up here in a few weeks in Tucson. There are little handheld Raman units that people are using walking around the mineral show. And if you have a database, you can identify minerals quite quickly just by pointing this device at the sample and getting a Raman spectrum. But because you have a microscope, a gemological microscope, what's very important is you can focus a laser on micro features. In this case, this is a multi-phase fluid inclusion in an emerald. And you can capture the spectrum, solid calcite, solid salt, a gas bubble, and the emerald by just analyzing different spots with this laser, because it's aligned with the optics of the crosshairs of the microscope. We can also do what's called photoluminescence, which is fluorescence to a laser light. This is very valuable for looking at natural treated and synthetic diamonds. We actually use a range of lasers because they each excite the optical defects in a different part of the spectrum. But again, these defects are a fingerprint as what has happened to the diamond in the earth, or during synthesis, or during treatment. We also have a way of kind of doing a photoluminescence map. So I show you on the upper left just a PL spectrum, and I've got a couple of features at 880 nanometers circled. You can set this device to only look at that feature. and you can capture that feature in the diamond. And then you can move the location, as shown in the upper right, across the surface of the diamond. And you can create a intensity map shown at the bottom. So on the left is a fluorescence image of a high pressure, high temperature grown synthetic diamond, as you see an instrument called a diamond view. You see a crosshatch structure, which is a characteristic feature of a synthetic diamond. And on the right, you have a false color PL intensity map of the distribution of the defects, which again correspond very closely to the structure of the diamond. And it's amazing to me that you have a technique that allows you to look at atomic level defects in their distribution. But we've actually kind of now gone one step farther. We are making 3D PL mapping. We've developed, one of my colleagues has developed a new instrument. It's called hyperspectral imaging. So on the left is kind of this little diagram of all these colored cubes representing different defects in a material. So we can kind of scan a point, but we can also not just scan at the surface, but also in depth in the vertical axis. But what this instrument also does is allows us to capture these defects along a line spectrum. So what we were doing a moment ago is just kind of going back and forth, point scanning to collect this image. But now we can go in a line. In this next slide, these are some of the first false color maps of the optical distribution of defects at different levels within a diamond. Hardly anyone in the world has ever seen these kind of pictures before, because I think this instrument is quite unique that allows us to do PL mapping in 3 dimensions in a depth in a gemstone. We also have a scanning electron microscope, very high magnifications. You have an electron beam, it interacts with the material, but you can image changes in topography, composition, and structure. So this is just an example of a diamond plate in different ways that you can use, and we can, kind of use this very high magnification technique to characterize gems. We also do X-ray diffraction, which is a standard method for characterizing all types of materials. X-rays have been known about 110 or 15 years. Elements, the atoms in a crystal structure are aligned typically in planes. And if you have an incident beam of X-rays, at certain angles, that X-ray beam is going to be reflected. So the equation there at the top, the Bragg equation, you have the incident X-rays, the lambda naught, you have the angle, and you can calculate the sine of the angle, and you can solve this equation for the D, which is the spacing of the atoms in the crystal structure. So if you have a powder, or if you're able to rotate the material around, so you're sampling a lot of different directions in the crystal lattice, you can calculate the unit cell parameters and all the D spacings. And this is the standard way that minerals have been identified. It doesn't tell you about chemistry, it tells you about crystal structure. We also have a high temperature furnace where we're able to do heating experiments up to high temperatures, kind of controlled heating on gem materials. And this is just an example. Some of my colleagues, we tried taking a synthetic spinel colorless material and diffusing nickel into it and producing this kind of sapphire blue looking color. One of the newer things we're looking at now is looking at isotopes and analyzing isotopes. And we're kind of focusing on the stable isotopes, in particular oxygen. Most natural elements occur in different isotopes. In oxygen 18, these isotopes travel through the geologic and crustal environment in different ways because they have different masses. So you have a way of ejecting atoms and running those through a spectrometer. And the graph on the bottom just shows you the fact that in terms of sapphires from Mogok and Burma, they have different oxygen isotope ranges. I should have mentioned early on, we try to make gem identifications based on as many types of features as possible. That's when it's a safer approach. We've also been doing a little radiocarbon dating for organic materials, in this case, saltwater pearls and shells. These are from an island off the coast of Venezuela in the Caribbean, which was one of the main reasons to draw the explorers from Europe like Christopher Columbus to the Americas. They were looking for these pearls. And we can radioactive carbon-14 date powders from a pearl or a shell to get kind of a formation age. And this is something we've reported on. We've also been starting to look at DNA analysis. I'm not any DNA expert, but if you extract DNA material from an organic material, you can get some indication for a pearl of the species of the pearl, the smallest species that produce the pearl. So I'm about out of my time here, but just in summary, the acquisition of scientific instrumentation in combination with classical gemological methods has advanced gemstone testing to new levels. But I think it's vital you have proper data collection and interpretation procedures, along with regular instrument calibration. These are essential for getting good results. And we try to rely on a wide variety of techniques. But the most significant challenge that any organization has is going to do gem testing with scientific instruments is this challenge of building your own database of information, typically with your own instruments. And the best samples come from gems of known origin. And I think with that, 1982, 2023, thank you very much.
Shigle, I think it's a wonderful journey. You took us through the entire gamut of gemology, and probably we are fortunate that a person of your stature, could give this kind of an excellent lecture. I think as you know that one learns standing on the shoulder of a giant. I think you are a giant on the field of gemology. Thank you very much.
Well, again, I just want to emphasize they should look at the articles on gems and gemology on our website, and you can read the results. You can actually see the studies. But if they have any questions, I'd be glad to probably easier to write out answers for them. But I'd just like to thank the audience and you for this opportunity to join you today, and I hope you have a successful conference.
Yes, thank you. And the last thing is the Department of Geology of this university would like to felicitate you by giving a small token of memento, which actually we will be sending you by courier to your place. And here as a formality, I would request Professor Karan to hand over the memento to the head of the department. It's a formality, and this will reach you maybe within few days. So on your behalf, the memento will be received by the head of the department of geology.
Well, thank you so much. And I'll try to send you a picture of me holding that when I receive it.
This is the one actually you'll be getting it, and I hope you will like it because this is a specialty of this state. And these are actually silver wares. We call it as a filigree. I think when you receive that, you would understand the beauty of this memento and prepared by the artisans of the Odisha. So thank you very much, Dr. Shigle. It has been a wonderful lecture. Thank you.
Well, If you have any questions that we can help you with, please
Sure.
don't hesitate to contact us.
I think the students would be writing, and maybe within a day or two, you'll be receiving few of the questions, and I'm sure you would love to answer them. Thank you very much.
Thank you. I probably will leave you now because it's getting later here.
Yes, yes. Thank you. I know it is late there. So, once again, thank you very much. Bye-bye.
Thank you.
Good night. Good night. For the information of the audience, we are not taking a tea break now, so we will be going for the next online lecture. He is Mr. Geology Bara. He is the Chief Technical Officer of Pura Gem. If you see the souvenir has a ruby picture. This is the ruby, which is about 101 carat, with the Pura Gem got from Tanzania. And they sold it for $34 million. So, Mr. Baral would be speaking on the mining part of the gemstone resources. I think I would request Mr. Dibojati Baral, he is now in Dubai. He will give his presentation. Mr. Baral, please.
Hello, good morning, everyone. Can you hear me well?
Yes, sir, audible.
Thank you so much. I think it is my pleasure and an honor to present, my understanding of the gemstone world in this August audience, and also it is honor to follow up from a learned gemstone specialist. It's a difficult task, but I will do it. I will try to present, my understanding of a very difficult and complex world of gemstones. And this I have gathered through working in this industry, primarily for exploration and development in many countries for last 11 years. So I would try to make it very generic, not very specific to any particular gemstone, but try to get my experiences across of how we have been working on this wonderful commodity, and how we need to why I think it needs to be discussed, because there is a lot of mystery surrounding this gemstone sector. Let me try to share my screen so that I can put my presentation. Is there any option to share my screen? Yeah. Can you see my screen?
Yes, sir.
Great. Thank you. Yes, I think what I will run through. I think I'll have 30 minutes. I guess I'll try to wrap it in 25 minutes so that I can have 5 minutes of interaction. What I thought important for us is that we all, awed by the gemstones. When you see, I'll not specifically talk about any particular gemstone, but all the characteristics and all the resources that we saw for gemstones. How do you develop? So my focus is primarily on the development of gemstone resources. So what comes to my mind or anybody's mind when we talk about gemstones is that they're bright, they're beautiful, they're mysterious in many senses. They have got a lot of uses, including astrological, starting from industrial to beauty and gemological and in jewelries. We can see them divided with precious and semi-precious. We call ruby, emerald, sapphire, which is on my screen, both in a rough and a cut form. I don't know why they're called precious, but they're the one who has got bigger revenue potential, so they sell it at higher prices. And there is semi-precious. Rest of all the color and bright stones are another semi-precious category. we tend to believe they're expensive, and rightly so. But when you see the presentation, you feel that not all the gemstones are expensive, not all the qualities are expensive. The price difference between the lowest quality and the highest quality can be as high as 1 million times. So the lowest one is sells, let's say, for $1, the highest one would sell for $1 million. So with all this background, what we understand is...
Can you make it full screen, sir?
Okay, I will do it. Just a second. Is it better?
No, sir, it's not.
Bigger?
It's not coming. I think you have not shared the full entire screen.
Right.
Okay, let me do it again.
All right.
Yes, sir, it's coming.
It has come? Okay. Okay, I think, so what I was telling is that we tend to believe that they're expensive because they are rare, and rarity is definitely one of the characters of the gemstones which makes it valuable. But when I go to my just a slide which I borrowed from Dr. Jenda, is just put a slide showing where are these gemstones. So if I put every point into the map, I've taken it from Mr. Das. Is that we can see that they're distributed all across the globe in different parts. Some of them are famous, some of them are not. But at least, we really cannot see that it is very rare. So what makes it limited, what makes it rare, and what makes it expensive is obviously some kind of a combination of different characteristics. We call it 4C. We call it color, clarity, carat and cut. We know all these things. But apart from that, there is also another factor which plays is the provenance, like where it is coming from. So obviously Kashmir sapphire is much more valued than the Nigerian sapphire maybe, or Montana sapphire. Similarly, Burmese rubies were one of the sought after rubies in the past. My point is, they're not only rare, they're also provenance plays a role in deciding what value it has. Why I'm placing a lot of importance on value? Because I'm going to talk about how to develop a mineral resource. So I do have to consider on the economic potential of developing a gemstone mine or gemstone resource. So all my focus is not really focused towards the beauty of the gemstones, but how to take this beauty out of the ground with an economic potential. Before going into the details of it, I just wanted to present a picture of the gemstone world, what we call an anatomy of a colored gemstone sector. What I'm showing in 3 different graphs here is the geography on the top left, like where they are mined. If you look at, I've taken, or at least taken from a report which talks about diamond, ruby, emerald, and sapphire. Then there is a geographic distribution of the production volume, where it is coming from. Like let's say the rubies are coming from Burma and Mozambique and other East African countries. The emeralds are primarily coming from Zambia and Colombia. And sapphires are coming from Australia, Sri Lanka, and Madagascar. So this is where the volumes are distributed, and I have the privilege and good luck to work on most of the bigger deposits in emerald, ruby, and sapphires in all the countries. So that's where they are being mined, and my experience comes from them. But if you look at the value chain, this is different. So this product then comes to a different geography where the value addition happens, like cut, polish, and set into jewelry. So if you look at emerald, they come to India. If it is ruby and sapphire, it goes to Thailand. The diamond is all cut in India in one Western cluster in India. So that's the way the product comes from somewhere. It goes to another country, gets value added and sold. But if you look at who mines them, or where do you get them? So what we know for sure is that this industry in the initial stages was only reliant on artisanal miners. Artisanal miners, you can call it, community miners, citizen miners. Some even, treat them as so these people, they kind of, and I'll explain later in my talk is how they're most important in terms of development of any gemstone resource. So what we have seen is, as the industry gets more organized and gets more systematic, the role or the share of the artisanal miners reduces, as you can see in case of the diamond, because it's a very old industry, gone into a very structured and structural changes in terms of investment and mining. So they have a lot of international companies are mining, and the share of the artisanal miners have reduced. In contrast, sapphire have not been taken up in that way. So sapphires are still mined mostly by the artisanal miners. Whereas the emerald, having two companies, Gemfields and Fura, with them coming in, the international companies have got much more, percentage of share of mining revenue. And ruby is also similar. The centers are moved broadly from Myanmar to Mozambique with a new discovery. And there also the international companies like Fura and Gemfields have mined most of the rubies coming out of that. On the left-hand side, I'm talking about the gemstone sector, color gemstone sector. So I will now dissociate from diamond completely. I'll only focus on the color gemstone. They are discovered by and worked by artisanal miners. Their access to land is sometimes not legal. Their mining is considered not responsible because they don't, care for a lot of the factors that we will discuss later. As I said, that they are highly and extremely variable unit value, and they are very difficult to evaluate. I'll come to that also. They pass through complex processing options, both from ore to product and then enhancement of the product. But we also realize that this transfer from the mining of the emerald, sapphires and rubies, when the transfer to the processing centers of India and Thailand, they are not very transparent distribution systems. That's why the industry is highly fragmented, but very specialized. And a lot of the jewelry industry is actually the family-owned enterprises. So that's the kind of an overview of the gemstone sector we see. I'll try to break it down into simpler terms. And so I've got like very few slides. I have 11 slides only. So what I will tell you is that, I don't want to stress on this slide too much because gemstones are special, we all know it, because they manifest themselves as a colorful, bright, and an attractive, commodity. But what I'm just trying to tell you is that the characters which make it special, or the characters which makes it attractive, is very difficult to quantify. There is ways to quantify them, but they're very subjective parameters. And in terms of identifying them, what we think is that what are the parameters which identify and help us identify the deposit is, let's say, the color, the sparkle, the hardness, or the transparency. Is there any way I can identify those parameters in a geological setup, or any method which helps me identifying those parameters in a mineral deposit? Probably no. So what we have to do is, when we are looking for gemstones for the geological resource and mining target, we have to rely on indirect ways of how to find them. Like, let's say, physical characteristics. So we know that ruby and sapphires are heavy; they have a high specific gravity. So what we assume that they must have been weathered and concentrated in some place, either colluvial or alluvial environment. So my point is, they not only are very special, but they have, what makes them special is not difficult to define in geological terms. That's the first point. The second is obviously they're incredibly, so I'm just, because I'm trying to put all the gemstones into one basket, I'm saying that they're very difficult in terms of rightly so, because they have different geological formation, their genesis are different, the characteristics of deposits are different, distributed between primary and secondary deposits. But what all these variations is that we have to do not have a standard template for defining the exploration process for the gemstones. We have a standard template, let's say for gold. Even if you take one particular style of mineralization for gold, let's say VMS, there is a particular way in which we'll have to systematically approach a VMS type of gold deposit. But we do not have a standard template available as yet for any gemstone. So the other thing that which controls the price and that controls the economic viability of any deposit is also very difficult to control. Let's say transparency. Like, it's very difficult to predict even if we collect 1 kg or 5,000 carats of gemstones, how much of them would be brighter colors, how much of them would have more transparency, because this is not a geological process which controls them, or it's not very directly linked, or it's not very easily correlated. So that's why I'm saying they're special and they are incredibly varied, and they have a very high variable pricing curve. When we talk about all this complex situation and we want to think that whether to mine a deposit or not, and we want to develop the mine as a gemstone target, is there any standard formula that I can follow? Probably not. In a typical mineral resource development project, be it bulk minerals or base metals or precious metals, what we are talking about is there is a concept, we have a pre-discovery phase, there is a discovery, where we have, discovery phase, we have a resource definition, we have to, bring in the drilling rigs, we have infill drilling, we have, geostatistics, we have modeling, we have a resource, then we take it to a feasibility stage, whether this resource can be mined effectively, whether the ore can be processed effectively, whether this is really a viable project. So we call it a feasibility. But because in this gemstone sector, there is no resource to start with, it's even very difficult to go to the feasibility and development and startup and processes. And that also makes it difficult for anyone to believe. So, if some investor wants to believe on you that you are telling him the truth, he would ask, like, can you tell me the reserves? He's not even talking about resources. Can you tell me what price it is going to achieve in the market? And can you tell me what is your premium or the best quality stone out of this whole your thinking is going to produce? So what I'm trying to tell you is that the timeline and the activities for gemstone deposits are completely different than any other commodity that we know. Obviously, with that also are the different risks associated with the development of a project. But we know that a lot of these risks associated cannot be waived off in a gemstone operation. They are inherently a very risky proposition. That's why the banks obviously have a funding risk, so they don't give money to develop a mineral resource. There are technical risks because technically a lot of the parameters can only be derived from the resources which we do not have. Obviously, exploration risks are also there because we do not know how a limited data set can predict the future of a long scale operation. So it's combining everything. What we are saying is that we do not have a standard template for developing a gemstone sector. If I divide them into secondary and primary deposits, secondary we know obviously some characteristics like gravity or specific gravity of the gemstones can be an concentrating factor. Some cases like emeralds, they can never be concentrated in a gravity process. So those are the things which we have certain templates available for Ruby and Sapphire because we are looking them as a paleo channel or paleo alluvial concentrated deposit. So there's some templates are available, like the Mozambique and Australia. They're kind of a similar strategy, but inherently, but they're slightly different in their approach. But some of the primary deposits, like we are mining in Zambia, the emerald deposit is a huge operation with big resources. There, we can actually borrow some of the exploration and mining practices from the large scale operations and still use them in the large scale primary deposits. If I go to, like, if this is so complex, how we are doing it, or what is the best way, according to me, is to follow, it comes from a long history of artisanal operations by thousands, sometimes even hundreds of thousands of people in some of the countries. A case in example is Madagascar, which has taken these 3 photos. So they are brazing everything to soft rock to hard rock, marble, and digging consistently. And their knowledge is far more superior and far more deeper than even all the geologists that we try to hire and try to work on this deposit, because they have been doing this in a systematic, or not a systematic, but at least in a sustained way for a long time, through generations probably. So what we see is, they give us a lot of indication. So my first takeaway is that the gemstones are rare, they're unique, they're complex, but there is no standard template available. But there is a catch, is that we can actually rely on the artisanal miners for discovering the deposits, which can be large scale. So what I'm saying is that most of the large established mining districts of the world, for any mineral, emerald, ruby, sapphire, anything that you see is the gift of the artisanal miners discovering it. Not only they discover it, they provide a very good insight into operation sustainability. Like some deposits, people go there, mine, and they vanish in few months. But we see that a lot of the operations have actually sustained for a long time. They also give us a potential pricing, because the product goes to, for a long time, goes to the markets, and what price they're sold for. They also give us a lot of things about how you are going to process them. So if I go and watch them for months, then I can know that what is their preferred way of washing, what is the preferred way of segregating the fractions, minor sizes and all. So I think the best option for us to develop the artisanal, the gemstone operations, is to understand and learn from the artisanal miners. So that's my second takeaway, is that we have to learn completely from the artisanal miners. We have to then go through what we call a exploration or a bulk sampling phase. So which means that it is not artisanal, it is not a large scale, big, humongous operation, but it is somewhere in the middle. And the bulk sampling sizes primarily varies between, let's say, 10 to 30,000 tons of ore. So first we have to watch the miners, artisanal miners, understand what they're interested in. That's the ore for us. How can I mine 15 to 30,000 tons of that kind of a material and process? And on the way, I just keep note of everything. I keep note of, let's say, what is my mining rate? What is my mining cost? What is my ore recovery? What is my OB versus ore distribution? The stripping ratio. What is my equipment productivity? So all these things, I just keep note of them, and And just, that becomes my database on which we have to design the large operation. So you can see on the bottom, the right side is a bit of a bigger bulk sample done by the artisanal miners, whereas towards the left is the excavator is doing a small sample pit where we will understand the characteristics of the deposit. It's a bit of a complex slide, but I just taken this slide from a typical, mine development, workflow. What I'm saying is, a lot of this, maybe I can draw if I can quickly. Sorry, yeah. So towards the left is exploration and feasibility. What I'm saying is that if you watch enough of this artisanal miners, you can actually understand the geological information, reconnaissance, prospective area. They also give you a lot of data for subsurface information because you saw them digging down right up to 30-40 meters, so that you can use them as a drilling source. Similarly, we can get a lot of information from them about the mineral extraction, processing, how they are processing them in the nearby river. So this information is already pre-available with them. What we can use this to information and start working on a design and planning stages. So my point is, a lot of this value chain has all been taken care of by the artisanal operators. We just have to go and start working on these modules and create a template. Once we have in this bulk sampling phase, which is this phase here in the middle, then it is easy because, as I said, the processing parameters are not very difficult. So for the gemstone operation, so it doesn't really need a scoping study for the processing. It just goes into the last phase, which is mine closure and post mining land use, which is also two of my focus when I'm doing a gemstone mine, because gemstones are only for the for a luxury industry, and there is obviously a lot of scrutiny for how you mine and how you do it, unless it's not a iron ore mine. So you have to be very focused. So one way my focus is to make it large scale and mechanized towards the top left corner to make it economically viable. Whereas as we progress, when it becomes a big mine, our focus shifts to how do we make it sustainable in every term. How do we make it more ethical? Talk about child labor, human rights and all those issues, because of you are working in close proximity with artisanal miners most of the time. And then also how to make it more responsible. I cover responsible for everything, like how could we be more environmentally responsible? How could we be more responsible towards the society? So I think it covers a lot of aspects which we need to be focusing on as soon as the project is established. Okay. So I'm running a little bit behind, but I'll rush through. The third point, what I'm talking about, is the ore processing and value addition. When I mean ore processing, it is about once I've identified at the site what is the ore, how to kind of sort the ore so that take out the product out of them, the gemstones out of them. And once I've identified the gemstones of all the qualities, we need to go through what we call a value addition process. Value addition can be simply grading or separating them into grades which the market wants, or it could be value addition through treatment. So all this also is a very significant part of any development story for any mine. So what we need to understand is every gemstone has got unique physical, chemical, and color and fluorescence characteristics. So what we do is that we try to study them, and ultimately different parameters tells us how to extract them. So I'll just put two photos. Most of the ruby and sapphires are through gravity separation, through jigging or dense media separator, because they're heavy. So we need to take them out. So a typical setup would be something like this. This is the Fura plant from Australia. But when the physical characteristics are also not very prominent and like emerald, but they have obviously color and fluorescence, So they fluoresce at a certain wavelength. Dr. Sigle was presenting that one. So what we do is that we just put them through a process where we put fluorescent light and a camera and a computer. So what they do is that as soon as it sees the fluorescence, it just ejects to a different box. So that's the optical sorting that we do. But what I'm saying is that we have to study all this, physical and chemical and color fluorescence properties to identify what is the best way to segregate them. So then this, once you have found your stones, what they go through the final sorting, grading, and classification, so that you can supply to the targeted buyer. We do have a lot of other ways to understand how we can also treat them to make it better. Like we can improve the color, we can improve the clarity and the saturation. So if there is any way we can do it, we will also do it through the value addition process. Last but not the least, what I'm saying is, if I have to develop this gemstone resource, I think about the bulk sampling phase where we are collecting every information. It's like a very minute details of mining, geology, processing, grade, and we create a comprehensive database, analyze them, and decide that, what is my mining parameters? What are my cost parameters? What is my geological understanding? All these things will be, telling me how do I develop this mine? What is the path it follows? And this will also tell that if you have to scale up, because bulk sampling is a small scale, it doesn't really make money. But to make a profitable or a sustainable economic deposit, we have to take this to scale. So this bulk sampling phase defines my scale and throughput, which defines the profitability of the operation. So with my experience, it normally takes a couple of years of bulk sampling with a robust database, which is also an exploration phase. We can decide on the large scale operation and which can be optimized for processing and value addition workflows. That's kind of a summary of the gemstone sector. If we have to develop this sector, what we are saying is that gemstone industry has got a lot of complexities for exploration, mining, and valuation, but at least it has evolved a long way in last 30 years when I say colored gemstones. But if I look at diamonds, they themselves have developed over a long period, probably close to now 90 years. And that's why you see that industry is much more developed. Their sciences is much more refined. Diamond geology is well known. Diamond mining is well known. Diamond processing is well established. The grading system is standardized. So my point is, emerald, ruby, and sapphire, the color gemstone sector is yet to catch up on the understanding. It is improving in last 20 years, but I think there is a long way to go. What I'm saying is that with diamond leading this knowledge curve, knowledge and trade, because they go hand in hand, it is easy to follow good examples in color gemstones like Zambian, Colombian emerald, mined by Gemfield and Fura. There are Mozambican rubies also mined by Gemfield and Fura. There are Australian sapphires mined by Fura. So there are a lot of good examples which are now being available. So eventually they will, create a template which others can learn and do it. We have to keep thinking about the new business models. We have to invest on, understanding of the ore genesis, how to find out in a quicker way, how even create a resource. We are saying that there's no resources available, but Zambia has got a mineral resource for emeralds because they have drilled close to 90 kilometers. Is there any way to develop a resource, drilling less, doing some more geophysics? I don't know. But we have to understand that resource model. Obviously, once the resources are ready, probably people will trust more industry, and the banks will probably have more financing available. The investors will come in to invest, can be listed in the stock market as well. The governance of the whole, gemstone value chain, the policy, mine development, the processing, the value addition, distribution, and revenue, these are slowly getting developed, and I'm very sure in the next 5 years there will be standard templates available for each of the other models. Having said that, even if it looks very difficult, gemstones have the shortest gestation period. In my lifetime, I have, in a very short period of 2 to 3 years, we have acquired, developed, mined, produced, sold, and got the revenue back to the mine in less than even 2.5 years, 2 years. So it is very unknown or unheard in other industries. The base metal and the gold industry takes 10 to 15 years of gestation period. So what I'm saying is that gemstones are very short gestation period. They recover investment faster, but they are the riskiest business model. We have to also appreciate that. I think what also is important, I did not stress enough on that, is that when you do this in a right way, ethical, sustainable, and responsible way, what we can do is that the pricing of the gemstones can also be multiplied even by 15 to 20 times if we do it right. And that's one of the factors which will drive the profitability and development of the colored gemstone sector. Thank you so much. That's all from my side. I'm happy for questions from the audience.
Thank you very much, Mr. Barao. I think before we give him a small memento, I must say that he gave a wonderful presentation. And what he explained is that the colored gemstone, which you do mine through the artisan, by the people who do some kind of method mining, and to the very organized mining system, mechanized, which he highlighted. And in between, he highlighted the bulk sampling is one of the major keys which will actually help you for assessing the color gemstone. But before I conclude, I must highlight Mr. Barao. He is from Odisha and he has done his post-graduation from Roorkee IIT. And right from the beginning, he has been in the different multinational companies. And earlier he was in the gem trade and he was a part of one of the biggest emerald mines in Zambia. And right now he is with the Pura Gem. Now they are the biggest colored gemstone mining unit in the world now. I think the souvenir, as I said, you saw the red ruby. It is discovered by them, which is there in the the board. You can see the ruby. It is discovered by the Pura Gem. So, Mr. Barao, once again, thank you very much. And as a token of appreciation, we would like to give you a memento virtually. We can reach you, of course, at a time. I request Professor Karan to give this memento to the head of the geology department, Dr. Rosalyn Das. So, if you will give it up.
Thank you, sir. Thank you so much. Thank you for the honor.
Thank you very much.
Nice. Function plus 10 minutes.
Now I speak that now I give a email for 10 minutes and wouldn't be come and solve that. So it is dead and getting a pay for the
I think that's a good idea that we be seated here. Once we go out, we lose time for the next speaker. Dr. Karan would be our next speaker, and followed by Mrs. Rudra and Dr. Vibhuti Raj. So they are very, very interesting talks. So be here and enjoy your teaching. Right in the hall of coffee of me. Thank you.
Packet distribute कर दे video.
बंद कर देना नहीं
We have written continuous now. Every comment break ଅଛି ତାପରେ include
Last time they just
Yes, sir.
With good luster, you can collect all these stones in a small packet. You come here. So what are these stones? Why they are so expensive? These are rare stones because of diamond. That too is diamond, colored diamond, which is much more expensive, much rarer. So take this thing. And the country is known for diamond and other stones. So we are trading since more than 2,000 years all the time. So we should have a good knowledge of what are metal stones. We should see the next one. Next slide. We people in the modern time, even in the ancient times, the precious stones were well known and they were taken and here you can see in Central American they are all beautiful jade, pink color jade. You can exchange the difference and have your money. So even for the earlier time people, they also went on using this thing. So these are known as precious stones. So you can see the next one. Here's painting done about 4th century ago. You look at the floods. Where the movements are due, gemstones are due. Two colors are still standing out. For example, blue color or blue. So that is from the mountain. Similarly, iron oxide is used for red color. So these colors are still standing out beyond the century. So they are used for not only as government. In Europe, they are also used as treatments. And next one I can see. Yes, of about copper meter by the mountains are made up of rubies, and ocean is made up of emerald, Colombian emerald. So 4th centuries ago, Rajesh of Iran, he invaded India, annexed Delhi, and took away a lot of wealth from here. Wealth in what we couldn't take in the form of wheat or anything. Put grains, he took in the form of precious stones. So these were collected, the Mughals at that time. And now they start to Pakir, Mohan, and plenty of other countries. We call it blood loads now. In that time, camel loads of gemstones they took. And then, so there, after some time, utilizing ruby, there and then diamond, they polish this blue. And they claim to full of diamonds in the night. So such that we have in place. And even today we have. And we are trading all over the world. So let's see the next one. Next. So here we are having this thing made out of diamond, ruby, sapphire, and emerald. So these are four precious stones, what we call real precious. Diamond, and then ruby and sapphire, and then emerald. So these are four precious stones, of which three of them are called color stones. So they are known for their color and luster. Whereas diamond usually they were white and then some color in the next stage. Now we shall see what color is, how the color is obtained with these stones. So we shall study color in that. Here is the structure of beryl. Beryl is made out of beryllium, aluminum, silica, and oxygen. They are arranged in a particular manner. If you take silicon and oxygen, they form tetrahedral structure. So 6 such tetrahedra, they are together with ring. So one of the 6 of them can be down, the 6 of them can be down. Then they are connected by aluminum and beryllium. So aluminum and beryllium, they are surrounded by oxygen, which are at the end of these tetrahedra. So, tetrahedral structure. And in aluminum, it is surrounded by beryllium and silica in the center of those tetrahedra and oxygen. So we just got one particular configuration. And if you take beryllium, it is surrounded by aluminum, silicon, and oxygen. So it is some structure around that. So like this is the field around this thing. Cations, all these anions are surrounded, and also it is surrounded by cations. So each one has its own specific field. So they are interacted in a different way, like electrons interact in different way. And when white light falls, so they get vibrated, and when there are from these questions, and then they are surrounded by this, and occasionally, in some cases, some of these elements are being replaced by what are called transition elements. So which one would be replaced? So aluminum ions are replaced by transition element like chromium. So chromium ion, if it replaces aluminum, it turns out to be clean. That's called emerald. And if it is replaced by iron, so that can become blue or yellow. Due to some reason, we will see that in later stage. So these transition elements, if they are there, they become colored. How these transition elements have what are called unpaired electrons in the D shell. These unpaired electrons, when white light falls, they jump higher level and fall back, jump to higher level and fall back. At this process, they absorb some part of white light, energy in the form of white lights. And when these things are some part of the white light when it is being absorbed, the remaining part comes out in the form of color. So if chromium is replacing this, it absorbs this blue and violet color and red color and green. So then it goes to this called if it is by iron, then it can become yellow and blue color. Because the spectrum of the color, these things are being absorbed and ultimately you get back this color. So this is called crystal field clearing. So you will see it in the next one. Here we have idiot or yellow colored so in this oxygen and iron surrounded by this thing, iron is replacing the aluminum, and there is exchange of electron from oxygen to iron. So that is called ultraviolet charge transfer. That is one electron from oxygen jumps to this iron and comes back. During this time, in the ultraviolet region of absorption, then ultimately it gives rise to yellow color. So that is now called billiard ball. So we shall see next one. So in this case, this is called intervalence charge transfer between two iron ions, whereas when there is exchange of electrons. In this process, it absorbs the orange color, orange and blue and green. Sorry, orange and red color, and it gives out blue color. So it is called aquamarine. So it is known as intravalence charge transfer. So this kind of absorption which are happening as long as this transition elements are there in the structure. Then you'll see next one. Here, manganese is another transition element. If it is there in the window as impurity, then it will give it to red color. It is called red impurity and blue spine. And also it will give rise to pinkish color or orange pink color or brown color. So here manganese is responsible for the color. And the next one here is the most important thing is environment. Environment if aluminum is being replaced by chromium or vanadium or iron, it can get green color. So if it is being replaced by chromium and vanadium, that green which is coming out is very sharp and harmless color. Whereas if iron is replacement, it also becomes green, but the green is not as visible of this color. So most important thing in geology is when it is aluminum is replaced by chromium or vanadium, the color that comes out is very fabulous color and it is called emerald. Okay. And next one. You can see here. Here we have red with various impurities and due to various things, then it has become different color. When these transition is not replaced, then it becomes colorless. That's called ocean. When that is replaces, it's called organic or very fine. When iron is replacing that aquamarine or video. Then there is one more reason. That's that radioactivity around that. When there is being bombarded by radioactivity, and it can get structural defects. Those structural defects will result in another type of blue color, which is called black so, when we have which fixed the star-like material, fixed one so these are the varieties, some varieties of the next one. Green color is due to chromium, vanadium, and iron. And if it's very green, it's called green vanadium. That's due to iron. And blue green is called aqua vanadium, is due to iron. So ferrous is very tiny. That's exactly in the green side. And yellow color is due to iron once again. Due to it's called golden meteor. And then we have red and pink color. This white and is due to magnetic impurity. And colorless is coordinate. And the other type of blue what we have is the color filters by the radioactive bombardment. So this is nice very good. Chromium is very used as green color, whereas there is another one called corundum, where aluminum, if it is replaced by chromium, it becomes red in color. So here crystal fluid is quite different. Why? Because here the composition of corundum is aluminum oxide, whereas in the composition is this thing. Vanadium, aluminum, silica, and oxygen. So there, the crystal fluid is quite different. Whereas here, crystal fluid is this aluminum is surrounded by oxygen. And when the impurity of chromium replaces aluminum, it becomes red in color. Then it becomes chromium. So even this corundum, if it is replaced by other ions, it can become differently colored, which we will talk about that tomorrow when we study color in detail. And next one, there is another one, which is beryllium aluminum oxide. So it's in between beryllium and corundum. So it is called beryllium aluminum oxide, whereas beryllium is called beryllium aluminum and silicon and oxygen. Whereas corundum has only aluminum and oxygen. All these three different crystal fields, when they are being replaced by this chromium, then they have different color types. So in beryl it is green, in corundum is red color. Here it comes in between these two things, so it becomes red color when it is incandescent like oxalate, and becomes green when you see that in daylight. So in daylight it looks green, whereas incandescent light it looks red. So this is beryllium aluminate, and this particular thing is known as alexandrite. So isobarium has this composition. When this aluminum is replaced by chromium, it becomes alexandrite. So in the daylight color and the incandescent light, it is different color. Okay, we'll get the next one. Now we will study color details tomorrow. And just this kind of thing, why do you go for only these important like this thing? Reason is they are not only having different color different days, but also they are harder than other stones. So what's the importance of all this? Supposing you make a stone and wear it in rain, it is likely to collect dust particles. When it collects dust particles, you take your pencil for something and keep on rubbing it. Okay, try to clean it. When you try to clean it, those minute dust particles try to scratch the stone. So in these dust particles, most common dust particle which is harder is quartz particles. And other particle play and all these things, they're softer. These softer things do not bother the stone, whereas the harder walls try to crack the stone. So those stones which are harder than quartz can remain for a longer time without being smashed. So because the hardness of these stones are much more, which are made, they are very diamond, like a spinel, and some acute stones are having higher hardness than other stones. So they can stay for a longer time. That means another important property for the gemstone to be developed is the hardness. So higher hardness, better it is. And here still what you are saying is these roots of ancient time with rubies around and diamond around, but the central one is red color, but it's not ruby but red color glass. So the glass is much softer, like these stones. So it has got too many snacks. So hardness is another important thing to get this stone. Not only color and this is different index in nature. So we'll see the next one. Here is a very beautiful red color. You would love to very in one way. But unfortunately, what is happening? There is extremely small. What is this? Which is cinema. The hardness is less than 2. So, which can be easily scratched by fingernail. If the particle sits on it, if we just try to remove, it will scratch the stone. So this thing is too soft to be almost. It is suddenly possible. Why this toxic organisms are mercury? So this mercury, this particle is toxic. And secondly, it is too soft. Although it is very beautifully red and high in that. So we'll get the next stop. This is another beautiful red color. So it is beautifully red and almost that cinema, it is it cannot be scratched by fingernail, but you can scratch it with a pen knife. Okay, so this is one of the and it is not too soft, at the same time not too hard. And the other thing is, it has got weak plates. What are these weak plates? They are areas. So if you try to cut this stone, sometimes it goes away from the what you want to cut and it cuts in its own way. So it gets cut along the cleavage much more easily when you are trying to cut with a soft blade. So because of this weak plane, then it cannot be cut so easily as other. And also when polishing it, when some of these cleavage cuts along that, it might break. So it is called weak planes. That's one thing. And second thing is the hardness is not too hard. So this also cannot be that good as that. And secondly, it reacts with acids much more easily because it's carbon. So all these things keep it down, but the color is extremely beautiful. The color is due to manganese in this case. Okay, we'll see the next one. Now here we have a beautiful plate. There is a high refractive index and extremely hard. Next to diamond is the hardest one. So this becomes a natural condition. Not only red, it occurs in other colors. So what is this? This corundum. When aluminum is replaced by chromium, it becomes ruby. And when it is replaced by iron, then it becomes bluish. And also it can occur in many other colors. So it is an ideal gemstone. And it is one of the most famous precious stone, which there are two important stones. One is sapphire and that is ruby. So it is ideal and it's very hard and high to specific gravity. Sorry, refractive index. Okay. So next one. You can see how visible it is. So then we can do it over there. So such this like this potatoes, both of them stand out. One of them is diamond, other is ruby, other is fire, other is emerald. So these four are called precious stones, which is being valued from the very beginning, okay, for centuries. And next one. Here we have a blue color corundum. So where the color is due to iron. So where there is electron transition between the two iron elements, and it gives a certain blue color with a higher refractive index and high hardness. So next one. This is having so many diseases. These touches and so many colors. So we are studying colors in detail in Mohan, where we see what we see. So these things are so after various colors is called allochromatic. Okay, what is allochromatic is obviously studying chromatic. So you can see so many varieties of next one. And other than the precious stones, not only Atom or very in geology, but also many of them have a wonderful this thing in industrial value. For example, we have ruby. So the ruby is what is that one? It's in the form of a sphere. So it is man-made synthetic ruby, which is being taken and put in missiles. It is made of missiles to put provides completion because it is actually hot when it is traveling to the atmosphere. Make both very smooth. So for they are using using solid. And then you know what where the what glass is made of sapphire, white sapphire. So which also avoid the and the other one what you are saying is with diamond base. So it's the best drill when you are dealing with your tools. So it can prepare your tools with the help of diamond drill. Without any kind of paint you have tools. It's that drill much faster than one thing very clean. And number one, here is the paragraph operation for which if you are using diamond mind. Okay. So it will use you can operate more easily without any much damage. So so we are using diamond only the jewelry, but it has much more application in the industry. Okay. So this thing also semiconductor property of this industrially, and there's a many other users. And that's the build for any kind of purpose. So that one. Now we see. We talk so much about this thing. Science. How big we are. There is two elements. One is how big they are. Because millions of dollars to contact with our beauty point. Such very dear something so much. So you can imagine how much this feature stones are costing itself. And next one. Here is another which is British pound. Okay, yes, we have, which is part of the black, black is blue, but that will, is finished, not blue. So this job is not study of the photo. So we have to study carefully and then we call properties. And next one is also important. This blue color which is given to a general of 6th century for Solomon. So he has used it as good. And we will talk about it later. We will take the next one. Now we say, here what was the yes, this thing that is but in this form, and they are making a stone with the help of what? Matchstick. Okay, matchstick is using that. What is saying is a diamond. You see, in that way, then this may be treated by people who are selling. Same thing in India, we are talking about tables here. So the people who find it, they don't get much. Whereas the trader gets all the materials. So next one. So even Europe and America, they collect stone and polish tumbler and they love it. And we people, still people bother. We don't have how we are benefit. And next one is another one. Even the insect loves stones. Because food has this instinct protected in the day. And when insect also very weak. So happy how we next one. So it's a great thing that we get to okay, let's see the last slide.
Thank you very much, sir, for presenting your expertise on geology, particularly on various properties of geology like hardness, localization, constraint, and color variation, how it comes. Thank you, sir. We are really privileged to have you with us. And tomorrow we will listen more from you, sir. We expect more from you. Now, I request Professor Bhubaneswar Rai, sir, Department of Geology, University of Lucknow, to present his lecture.
Thank you, madam. It's been a great pleasure once again to be here. I am so delighted that the subject that it's nearing lunchtime and the hall is full. After such a wonderful talk delivered by Dr. Karan, who is a legend, who is one of the finest gemologists that this country has. For me to be here seems to be a very small question as far as the speech is concerned. But as they have charted it down, where my lecture comes after this, so I'm sure it's not be as good as what we just saw. But I'm going to talk about the antiquity of gemstones, that how gemstones have been used by human beings. And in that regard, since most of the students sitting here are from geology and the experts who are sitting here, they are from geology background. that the early man was a geologist. Early man was able to identify the rocks, which even today many of us fail to do that. And the early man was using these rocks to the advantage of making tools and making some kind of jewelry, whatever position they had as part of the head of the plan or part of the various kinds of the rituals perhaps that they have. So while looking and digging out the history of gemstones, I was able to find that the Neanderthal man used to make some kind of jewelry to the advantage of, let's say, for us to know how deep into time the jewelry and gems that were used. It's not only gem, I am also using the term jewelry. Starting with the antiquity or jewels and gems, it goes back into prehistoric times. And this Neanderthal man made perforated beads from minerals and small sea techniques. He also made the tools using these rods. You can see some of the beads that were recovered. And later, there were some human figurines that you can see that were made by them. And even the tools had a kind of some very vivid depiction of having the angularity, especially using the cryptocrystalline silica, to the advantage of having a very sharp edge. And the record, the 23 snail shells beads in Morocco Bismon cave that were dated to be a lakh 50,000 years old that were found. Many of us may question whether are these really part of the jewelry, but the similarity of holes that were found in them, it gave an idea. And then when they were put under SEL, it was found that using very sharp tool, these holes were made. So from there, and I want to show you that cave from where they were found. You can see the place in the eastern part of the area where in this cave these snail shells with holes were found. Two of the ancient beads that come from the small cave on the slope of the Mount Carmel in Israel. The other comes from the site of Hugh Jebana in Algeria. And these are also one of the earliest known pieces of jewelry made by modern humans. These are modern humans, they are not Neanderthals. By Homo sapiens sapiens, identified by scientists, they were almost a lakh year old. As you can see, the three depicted these shells. For that, as you can see, they have been well studied and they show these are not tubercles, these are not part of the bill and these other kinds of gemology, these are holes made by human beings. And then the trade beads or slave beads, they were used for exchange of human beings who were actually slaves that were found from 1740 from Wichita village site in present-day Oklahoma, US. You can see if you carefully see the necklace at the bottom. So these slave beads were actually used for exchange of slaves. Then a necklace from the ostrich shell beads from East Africa are dated to be 75,000 years. You can see a string with huge number of these rounded with a hole, these very thin shell, such kind of beaded forms have been found. And when they were separated out from the stone age, we separate out the civilization suggests that 50,000-year-old Australian discs were like this, where the hole was sometimes large, sometimes they were small. They are not there. These discs are made by these Stone Age people. And because unless we have an evidence, and then that evidence has been dated, we cannot be very much sure how and when the humans started using it. And there are a few other varieties of this that have been reported across the world. That is Navy. That is one of the earliest known mineral base from Afghanistan, which is 6,000 BC, almost 8,000 people presented. They were systematically mined to make this kind of structures or features for as a part of jewelry. Some of the Carnelians and other pictures like silicon was used with the drilling in the disc shape from the Neolithic period about 5,000 BC. You can see they are actually the real ones, and they show how minerals which a little more hardness was used. This Egyptian bog bead, which is made about 15,000 BC, so about 3,500 years ago, consists of a green querce bead linked with the pattern of brown. That is, they are actually glazing technique being developed about 3,500 years ago. Then from Pompeii, these are the Roman glass beads that date to 200 CE. So that is this is the kind of features we find in earliest records. Now, this Armenian bead necklace was made about 1000 BC, which is among British colors. Carnelian was a very popular material among early bead makers. And by the dawn of the Bronze Age, roughly 3000 BC in Europe and the Middle East, design beads were used like this. So, evidence of early jewelry dates back to the ancient civilizations that flourished in the Mediterranean and Iran about 3000 to 400 BC. During this time, jewelry was crafted from basic stones, typically as amulets and seals. This 8,000-year-old pearl was found on Marwa Island and was displayed by Abu Dhabi. This has been dated as told by this morning that the dating of pearls can be done using isotopes. Israeli archaeologists have discovered a 2,000-year-old gold earring beneath a parking lot next to the walls of the Jerusalem's old city. That means well-defined jewelry was started almost 2,000 years ago with the beginning of the present millennium. About 9,000 years ago in southern Jordan, a young girl died and was buried in a crouched position on her left side with what turned out to be around 2,500 beads. The beads were found mainly lying on the child's neck and chest, and most were fashioned from this kind of feature, as you can see. That is, since the thread that might have been used must have decayed. So only beads were there, but since there were all 3-4 colors, so this is the kind of design that might be used by those people. Now, 1300-year-old necklace found in England. Experts call it once in a lifetime discovery. As you can see, the original finding and then after cleaning, how it came out. And around the same time, the metal and enamel work was started, as you can see in this very early finding. And along with other mineral-based material, this ivory is this particular piece of display is actually made from ivory, and the use of ivory right from very early times is also there. Now, a questionable but well dated material of this statue called as the Vigran is believed to be the oldest Hindu artist and dated by Americans 26,450 BC, much older than the Egyptian, Mesopotamian, or Indus Valley civilization. This is the one which is 1500 BC Indus Valley jewelry. It has been restructured or they have been put in an original form that might have been there. So you can see about 3,500 years ago, there was well-established gems in jewelry usage in our civilization in this part of the world. And the other evidence we have is the gold coin of Bactria, the Indo-Greek Kushan, Sasanian Gupta Mughal period. That is dated to 1575 to 1480. That's their time. Here you can see both the artists. On the right side is the baby, and on the left is the king. They are all wearing jewelry. This is the gold coin. I have seen it with my own eyes. I can show you that these are the real ones. And not only that, the jewelry from old paintings you can see is being used by women folk. The lockets and the strings, the beaded strings. And then one senior Lajja Godi idol, one of the earliest, a depiction of the belief of the reincarnation. You can see this is actually made in clay. So you can see even in clay, a lot of beaded jewelry is being used and also necklace is being used by women folk. You see the Gajara idol. As evidence, you can see many of these, the ladies, they are not having any clothes as such, but all of them are actually wearing the jewelry, especially the beaded one. So there are other evidence as a proxy record that jewelry is being used for a very, very long time. And the ancient idol of Lord Vishnu from Koshan recently been dug up in UP near Allahabad. This is the 12th century Vishnu idol. You can see the jewelry being worn by Vishnu Ji. And then we get into the Patiala Maharaja of Patiala. He had the best collection of jewelry from across the world. And you can see the kind of diamonds, the blue sapphire, the emerald, and many others. And the way Maharaja used to wear them. These are some of the examples that in later period too. India had a huge repository or the kind of usage of jewels. And as I was listening to one of the videos, it turned out that 90% of Britain's total revenue, it actually went from India. Their assets, they have gone from India when they left India They took every bit of it. And in all their museums, if you click on their own original material, 99% of their displays would be empty. So some of the best museums of the world have our resources, our gem resources being put in a display. You can see how Bhubaneswar, which is about 600-year old, used to be this beautiful emeralds and diamonds being worn by Mughal Empire, Mughal queens and those. There you can see the rubies. And I read an article in National Geographic in 1954 edition. It was in Iran's the government bank. They have a wall, and for the first time they were pictured and put in the National Geographic magazine. There were tumblers and tumblers filled with emeralds of the size of baseball. And they all were lifted by Navigata from this part of the insurance and was taken away back to Iran. The art of diamond mining dates back to as far as 296 BC, well dated, with India being the first country in the world. Should I stop? I can hear some. You have some questions? Yeah. Okay, not interesting. I can just the first country in the world to mine them, and we have historical evidence that shows that not only was the diamond drill invented here, in fact, but the craftsmen also taught the Romans how to use it. And as far as other gemstones, for more than 2,000 years, India was the sole supplier of gemstones. This is for history, and this is for reports that even today, Surat and Mumbai are the worst, are the best, diamond processing centers other than one in the Netherlands. So these are the India still holds that capacity. Now, the time of we look into the other part of the history, we have records of brooches, rings, necklaces, earrings, pendants, bracelets, cufflinks, hairpins, stories, even granite jewelry that got developed using gemstones and similar materials such as amber, coral, precious metals, enamels, in addition to the glass, such as fused glass, wood, shells, and other natural animal substances such as bones, ivory, natural clay, polymer clay that were used. So these are the kind of material and these kinds of designs that were used extensively by the population in this part. When we look and try to dig out where the description of these gemstones are there, for evidence sake, the Arthashastra and ancient Indian Sanskrit treatises on statecraft, finance, and economy explicitly details about the gemstones and their valuation system. In Atharvaveda, Garuda Purana, Brihan Samhita, Jyotika Parijata, and other many other ancient scriptures, details of gemstones with their astrological values have been given for everything. Just showing you some of the last slides. The way these ancient jewelry were put. This is Prabhu Ram and Krishna and Sita in gold, and you can see the diamond in red. Indigenous Indian diamond now being carved out by mechanical methods using state-of-the-art technology in Mumbai. The old leading designs where diamond was used, studded with the gold, white gold designs. Beautiful use of wire studded along with the diamonds in a ring. And then a brooch made of the Palla diamonds. And these are the world's best diamonds. And imagine out of the 10 best diamonds ever recorded in the world, 9 come from India, from the river bed, from where the Kohinoor was also discovered. And this is a replica of the Kohinoor, which was shown by Karan Saab a few moments ago. We have a Queen of England kept at the unenriched repository of the King's jewelry. So this is how we have to appreciate the antiquity that India has been a leader. Still, it is one of the leaders. And India's future lies in gemstones and jewelry. And the young crowd sitting here, I expect many of you getting into the discovery of new gems because Odisha is the only remaining part of the country where at least 10 different kinds of precious and semi-precious gemstones are still found. So I look forward to see this department coming out as the Vice Chancellor very kindly said that you would arrange anything that you require. So I thank the organizers to giving me an opportunity. Thank you.
Thank you so much, sir, for giving us with your presentation. And you have spoken please related that how the delivery and not. And just want to thank you. Thank you so much, sir. And now I would like to invite our next speaker, Madam Rama Roy Rudra, former Director GSI Kolkata, to deliver her talk on gemology and inclusion studies of gems. Without wasting time, I am just whatever I want to give, so that you can see more information. You can have more information. Now, geology is a field of study that focuses on gems. But unlike other sciences, the purpose of geology is not simply to acquire knowledge for the sake of it. Instead, geology aims to provide information that can be used to support the commercial value of the people. In case of the word of gems like gold, there is no listed value for it. It essentially depends on their species identification and authentication. What is authentication? In the world of gem, any sort of human intervention, other than cutting and polishing, always lowers this. Gem testing nowadays has become a core area of activity in the world of gemology. But unlike particularly the last 100 years, gemology has traveled a long way from Zen science to the multidisciplinary scientific and it has made a journey. Now, for doing gem testing, you need to have very good knowledge of mineralogy, some knowledge of crystal techniques, as well as you have to know something about the material science world. Otherwise, we cannot do it. However, this is very important. Now, for doing this, particularly for authenticating it is very important that you should examine the inner space or the what can I say, inclusion pattern of things. Because inclusion happens at the record, at the documents, so the time process as well as the space of their formation. So, at present, synthetic gemstones are the superlative examples of crystal growth. So, they are identified to their natural complex in almost every way. It includes their basic crystal structure as well as their mechanical. As a result, synthetic gemstone is identical to their natural counterpart in every way. All their discernible physical and optical properties. Whether it is color, whether it is specificity, whether it is refractive index, everything is identical to their natural. In fact, there exists only a subtle difference between the natural and synthetic. And that difference lies in their internal picture applications. All kind of gemstones, whether it is natural, it is man-made, or it is printed. All of them possess a characteristic type of information because they attract living information. And they are like barcode, each is living. So that's why I think the fingerprint work, which is like what is fingerprint work. So study of the internal feature of the gemstone. So study of the internal feature of the gemstone plays a decisive role in the analysis of their natural and man-made, or whether it is pristine or treated status. So, for instance, you might be thinking that gemstone, what is the difference between a gemstone and gem? A gem is a gemstone that has been carbon polished. So, you cannot do anything that will cause any damage to the sample. So, all your identification process should essentially be non-destructive. So in this case, what we can do with it, there is some advantage is there. Plus, most of the time, that is genes are very precise and clarity is a very important factor. Most of the genes are transferred to centers. You can study them directly in any sort of method. But personally, the way she was training in the morning, but I feel very comfortable with normal methods because even I cannot see, I cannot understand that it is how it is extinct, what it is behavior cross-border, where it is pure or not, then I have comfort. So I always use that normal petroleum. What is here today? Some of them are personal samples, but most of them are service samples, which we have received during our studies. My work will be in Geology. I two are taken from India. But all others might take an identity. Now, what you all know has to be expected naturally because you are from geological. Now, what you expecting naturally? There is other reasons. There are no features, fluid features like that. But you don't know what to be expected in the So these are the things that we will expect in the microwave experience. Now let's study this. And the water. Whereas other stores also displayed in the links and they indicate that the larger the store was treated, not it was magnet. It is the pristine character in natural things. Okay, next to the very wonderful chart. You can see that's a one. Chapter 1 was the block, chapter 1. But can you visit that? It has these inclusionary diamonds like it has come from the home of the mother in the nature. And this photograph was taken in cross colors, inserting the accessory plane to show you the strange nature of that staining of that sample. It has made such an arduous journey from such a great depth it has come to the surface. So much plastic deformation is there, it has endured. So that indication is that aluminum balance or double reflection. Don't think that diamond is this much of color. I have put one accessory plate so that it's type of photograph. Next, yes, and the aftermath. These are all included small inclusions of planes which have distinct minerals, which have some radioactivity. So that's why it has the next the structure of the host. And after bullets, I have taken the three pictures. These three pictures. But where the last one, these are not that's why
लंबा छोटा कर देता दिखा दो स्पेस पर
what can you say that the behind is the so always we try to find out software lexicons or software terminology or software lexicons to give our information. So in case of geology, instead of writing the word and it is exhibition feature, we always write that this is speed. Because the moment it is involved phase, that means minute amount of the other minerals are coming out, but in oriented direction. So it gives the little of static. And because of that stability, I can say suddenly that it will be a little bit of thing. And with that, we always call it that it is a fix. Both the things again, the first one is in Ruby, the second one is in Sapphire. Whereas the last one is also in Ruby, but here the direction of the cross, cutting of the insert is there it is 160, 120. But with the lower, this one, we call this one. Almost 90 degrees. And if you look at the result field, it's like large photograph. The result field is what can you say? The result field is routine. Whereas generally counting the result field of whereas in case of lower the result field is more white. Generally develop at the cross-cutting of the what should I say, at the cross-cutting of the film. Now, in this case, they remove direction you will find in one way, and another you will find answer. Next, this is I like this slide very much, one of my favorite. In that case, in the background, you will find an example. Whereas in the north, it is different intelligence. It's I always find some similarity of this illusion with the shoes of one currency. Shoes of the another thing I have already been, and when you explore the interior of a gemstone, when the interior inclusion in a feature of man-made material is very low. One process and one signature. Whereas if you want to, since natural Jews are creation of mother nature, they show have all the mother nature. They are family, they are baby, they are all alive. Always they want to speak to us something. The only thing is that we must know how to listen to that. And that again is what we should hear. For a trader, these are all activities. So they think the illusion of this deteriorates the quality. For a researcher, these are vision. But for an insignificant person, there these are education. Because whatever I ever imagine in my life, I have seen all the geological processes you can see. So it is I think you will also feel that celebration. Even it's very interesting. This I know you are not students. Are you aware of first reading mission? Or in few words, I will tell you. Should I tell you? Now you know very distant both intrinsic and extrinsic structure interpret. But since it's extrinsic factor is quite important in the growth of a crystal, perfection, homogeneity, form, and 145. Perfect crystal in nature. Even in rigorous chemical condition, we are going to get an ideal crystal. Whenever a crystal grows, it grows with some sort of defect. And that defect may range from point defect in microscope to gross defect in macroscope. These gross defects are usually represented by little bit of cavities which may or may not be filled with gas and these are called illusions. They can be primary, they can be secondary. Primary illusions is another thing. This is a very sentimental sample. These are very person sample who got down in the 2611 something in Mumbai. Sample. So what I have come from the abundance side. This but it is the inclusion pattern here. This is primary inclusion. What is the characteristic of the primary inclusion? The primary inclusions are always random, discrete, and they are small in structure in library size and figure in numbers. Look at here, again, there is a round and there is a square. The round is a gas. And the square is definitely that's how. And the background it cannot be made. Background and today morning manager was telling that whenever it's black shade is there, generally you can find very important. But around the black shade, you need to have in these cases many things. There are markers where platform is sitting. You need to have right of salt in there. All the things like the Tanzania, that ruby of Burma, Colombia, they are all institutions quite soft. So that salt is there. Now, another thing is secondary gradation. In case of secondary gradation, those are very many are small in size, very large in number, and they are always in trails. So generally, people just can't understand what they do. To me, they are looking at weeds of plastic. both the samples are with me. If I could convert the practical model, we can do it. The secondary contribution in geology we call it failure. But if I write that your sample has this much of partially get fractured, they will just judge. But they will not understand what it is so here with the things. If the figure is surface switching, then we inform. Otherwise, we do. Now, we say the links. Here is the diagram with regular phase, and whereas in the front it is irregular mineral phase. So, another thing is that the yellow supply there are too many inclusions are there. What is that? Failure is there, heat is there, and there is discrete mineral grains are there. So we have to understand another very important thing in geology, you need to identify what is the inclusive space. Then the presence itself will be. Here the growth features are shown. Angular growth feature, angular hexagonal growth in UV, and if you cut the samples from there, it will be hexagonal growth feature. If you cut the UV from there, it will have angular growth lines. Whereas if you cut the sample from there, it will have straight growth lines. Another thing is UV is very common. That green is very common. So it is shown here. And I have given the slide with maybe in the Odisha. Because diamond always perform a very long and architectural damage from landed to the surface. So that these are the stringy features. This is the typical distribution features. If possible, tomorrow morning we have a class, the practical class, that this set of these and their variation is in that. Whereas if one shows immediate similar type of feature, but that in that case it is positive variation. And the direction is also different. That is the growth feature, and this is the dissolution feature. Another thing is that those are the straining characteristics of diamond. And it will be more detailed. You are studying about okay. This is the character diamond. And the character diamond, the characteristic strain features like the D. T is the characteristic feature of the strain character diamond. This is diamond grade. Refraction, double refraction. Okay. Now, I will give you that slide, but we need to do micro. Because it is in all of artificial simply it is to surface and it is showing the surrounding zone. But you know that from our foreign days we have read about oxygen bubble. But you can see it here in your here, the blue portion it needs to have Fe2. And whereas in the yellow portion, it needs to have Fe3. So in this case, what happened? You know that the succession of these accreting layers indicates that they are under different and quite oxygen density connections. It is not required in geology, but geology is a very, very interesting fact. You gemology, if you write, it is a hexagonal zoning and Belgian surface. That for the geologist, viewing buffer in front of your eyes is so exciting. The thought that since you are from geology background, you should see. Regularly make this how many times from years yes. Makes the users from the factory. If the technique is implementation time, you will definitely get gas bubbles or gas clouds. Next is this is the top. Similarly, diffusion wall. Where those two are the smaller in glass, this is the purification in glass. photograph is taken from, that of photograph is taken from This is some English fingerprints in like English and Singhani food. The interesting feature is that if you look at the sample under with lens under fiber optic illumination, then you like white thing. But the moment you see them under microscope, that is the unique. And this is the hallmark of honeycomb type of texture. This is not a soda Napoleon. 100%. But this portion that is surrounded with the element of the crucible where it was being created. It is a child synthetic use of nothing. It is a very practical concept. It is a different company. We are following a different process. So, because of that, this is a stress shock. I told you that the synthetic engineer of the synthetic junctions are being This is the hydrothermal synthetic element. Their ingredients is always studied. Now, this is all the ladies. This is this iron treated. I have written here this written beauties are very fond of secret items. That means they change their look with that. The treatment which has been done, it goes out, it fades out. So the caveat enter is required. That means public should be, in your report, you should mention that. And for avoiding injury, these are very interesting. Here, these are all glass filling in fracture, glass, plants, oil, resin, etc. But this one, this is the serious foreign affairs down. It is diffusion of titanium in the system. But diffusion from outside, they are diffusing titanium in the lattice of the material. Next case is interesting. They diffuse beryllium on the surface. This is steam so that that type of that trapped hole fluorescence can be created. And reactive fluorescence always create yellow color. So I have written here, don't fear the beryllium diffuse apparent liquid by manufacture. So it is so prevalent, but at the same time we can identify it. Identification techniques are that these are the features you can see in the under the microscope. And this is sometimes geographic origin learning is very important for the valuation of the tools. That type of three-phase fluid question with square or not solid phase. These are hallmark of the Colombian emerald. Those are dichroids and they're salty. And the next one is she's posted that Zambian emerald from our academy always have this type of two-phase fluid which are in rectangular cavities which run in a particular direction. And that whenever inclusion occurrences are almost 90 degrees in that instead of moving, always ask for what you know, but the CMS passport. So CMS Thailand is the characteristic. This is one of the characteristics of the pattern. You can do the geography by activities. Tomorrow, sometime else, another deposit will be discovered, and the type of situation will be there. But till now, this is the law. Now, I want before completing, I want to tell you that in this presentation, you have seen The purposely I have used for trying to get very, very scientific thing. Why? Because geology is not only exactly or excellence. It refers is far-reaching fact. Feeling for the emotion, feeling for the texture, culture, as well as feeling with the quality of it. We hear in this world so many its position is always in a between and between position. In one hand, there is emotion, there is greed, there is number of things, politics, everything is there. Whereas in other hand, there is science, and science. Can you imagine without using any sophisticated instrument, the scale of the microscope, you can go from microscope, which will be spectroscope, and one refractometer and one barrel. You can travel from separation by color to barrel in no time. And there is no chance to make any mistake. In my labs, I have tested at least 53,000 they travel even very good. And I have seen at 1,37,000 of samples. The other samples I use recently. In our one, except binding up you, I have also made one mistake. Except binding up you, there was no need to be seen because we have never skipped any steps. But however convincing it is, tomorrow morning, we will write samples to you. And I can do it in the hand. Yes, I can do it in hand. The pocket lens, but I don't need a subject so that a person below sitting beneath a tree can identify James. I don't like it. Because understanding reading and definition only with the help of the microscope or understanding his diffusion or understanding his type of synthesis is not with simple instrument. Use simple instrument. We have used simple instrument. We are innovative. We have methodologies, and we are really sincerely with all of it. And throughout my life, I was never challenged. Very normal. So I hope it is in terms of that makes the study of gemology so different, so special, and so fascinating. It's a subject where you are smiling. Because beauty always activates your pleasure centers of the brain. It makes you happy. But we're dealing with the best version of other best version of human beings. So I hope that my level set everybody how many that service getting, how many that service getting, how many so much people in front of me. Initially, I became a little bit nervous. Now, nervousness has gone. Thank you.
Very much. Because Jen has told me that I will just come and say few words and conclude the session. Thank you very much, Mr. Das and the organizer. It's very fantastic ambience around. The environment is fantastic. And the speakers that you have heard is from international to national. All great gemologists. Professor Single, respected Param Sahib is just in front of me, Professor Vibhuti Roy, and of course our very, very dear Ramadandraji, who was associated with our Gem Department, Geological Survey of India for a very long time. And actually, this diamond age antiquity that he has described so much, that is being reflected in almost all the temples of our country. You go to any temple, see any structure, whether it is Mohan or Fakir, you will find all the remedies that so beautifully they are sort of decorated by various types of ornaments. So, but केयुराणि विभु सयन्ति पुरुषं हारान चंद्रोज्जला न स्नानं न विलेपनं न कुसुमं लालं कृता बुद्धजा पान्ये समणं करोति पुरुषं दासस्तुता राज्यते श्रियं ते भूषणानि सततं भूषणं भूषणं. So what is the main abhushan? What is the main ornament of ours? It's knowledge. Bhushan. What we are missing? Dr. Roy and Dr. Shindle, internationally acclaimed Gemology. So the title is given by our madam. So all these things, what is very important is your knowledge. विद्वद्वंस रूपद्वंस नैवतुल्य पदार्थन स्वदेशे पूज्यते राजा विद्वान सर्वत्र पूज्यते. It is the knowledge. So my dream towards all the students is to just make it a नशा. जिंदगी एक नशा है दोस्त, जब करता है न जाने क्या क्या आलम, और जब हो जाता है तो पता नहीं क्या हो जाता है. तो इसको नशा बनाओ. जिंदगी को नशा बनाना चाहिए, पैशन बनाना चाहिए. जैसे कि प्रोफेसर कपिल साहब, पैशन. You have seen so many beautiful gems that he himself has seen and he has taken the photograph. तो जिंदगी अगर नशा में होता तो जिंदगी का फायदा ही नहीं. क्या फायदा है जिंदगी में? इसी तरह खाओ पियो पियो, ऐसे ही इस तरह एनवायरमेंट बनाओ. You get a beautiful ambience. The moment I entered, I found that वाह, ये जियोलॉजी के लिए इतना अच्छा जगह कहाँ होगा? है तो मैं जिंदगी का साथ निभाता चला गया, हर जिक्र को धुएं में उड़ाकर चला गया. जो मिल गया उसी को मुकद्दम समझ लिया, जो हो गया उसको भुलाता चला गया. Geology is the only field where you can enjoy, and he has got beauty. Beauty you will see in geology, in flowers, in rivers, in Himalaya, in all the things, in militaries, in mountains, in rocks. पत्थर से दिल लगाया, दिल पे चोट खाई. Yes, पत्थर को पूछते और is there everywhere. Even पत्थर में भी है. सब everywhere see that love, see that God, see that bliss. Enjoy life, enjoy science. All the best. Thank you very much.
Thank you so much. So now we have heard from Siti Chandra Dr. Former Director General during the Survey of India. So I think now all the participants are encouraged and motivated towards geology and towards geology. Also, how sir has encouraged. Thank you so much, sir, for encouraging all of us, including me. Thank you, sir. And I also thank Bhubaneswar madam for enlightening us between the natural and synthetic gemstone identification under microscope specifically, how we can identify gemstones when a gas bubble is present or when a fluid intrusion is there. Thank you, madam. Now it's time for a lunch break. We have lunch here in front of our building in the lawn itself, and we'll come back after 45 minutes. So we'll be here at 2:40. 2:40 will be gathered here. So I request all the dignitaries to have the lunch in the hall.
रियल और सिंथेटिक
and geological problems on the balance level and many other self-historical. Not well, there are other topic like
It will be next month. How's
so you can see geological clarity and these are geological provinces. Here you can see this is the Odisha line of ID without this according to the part in the ground line of Eastern Ghat mobile number. This is another ground line where this is called other ground line where you can find number. This is connected on the north side, single track of Western Ghat on the west, northern west here. So that is this is a area mobile and then this one is not mobile and this other. So these are two ground line. So you know the ground lines are very structured metamorphic rocks. Normally you can see ground lines and something. Or see ground lines. They are not market. The wrong kind of travel is to us. Then you have to take it. Regional. So this ground line is an element for understanding the lower functional process. Because these are the ones which are now in or they have experience processes which are deep inside. Now they have come out with the surface, we can examine that. And how to know that if you want to come to that mineral temperature estimates with that calculated and logical and perhaps we know what the temperature what the temperature of the which they are. Sometimes we can understand what does happen. Now, this is our step about the. Now, this is the map of geological problem. This is part northern part. Northern part western marginal part is the eastern part of the northern part. And this light blue is the Eastern Ghat mobile belt. This is granular color, and these are the granite events. They are very important terminology now. Very accurate rocks are not in exact position with the globe. What does it mean? Rocks which are never to Canada and metamorphosed and Canada. They are now in typical contact of the ones which are in metamorphosed and the 20%. This is the atmosphere that we keep between contact. And now beside the month another technology problem has been identified for the data problem center and which system. So this other slide has this problem is the data problem. This is new American problem. Most of the guys like 2800 to 2000. Whereas the different pattern is very short. It starts in around 2500 or 600 and 60,000. Yes, always starting with the Dharma and start over the Dharma. Then you have hold on, someone can have the self-pity then the math of and this one I can tell you. It's not it's not problem. These are some of the words that are written in there are many granite rings from rocks which are one Water element is because they are not very correct. So those are the people that come. Most of it because after that, there are younger eight-type planets. This is not a bird planet. These are eight-type planets. That is 3,100 to 3,000. There are many galaxy bodies. Some are non-proliferous. So they are also not that. So your story starts from 3,600 goes up to 3,000. We can your problem sizes are sizes progressively becoming some. It is a joint, and adding up I tell you one person I will appear more. So this is the story of economy. Coming to them, who not have many controls in this area. They have a lot of planets, but the planets are very long. They are metallic planets. Unless the planets are very much aluminum, most of the aluminum is accepted with the shell. So you don't find aluminum considered minerals like silver, all. You don't get much of that. But recently, they have found they have like here, just that the commons. How that you come to that but there are many other factors that are still part of the we are telling in but not many. Are very themselves are not known. But we cannot avoid that problem. So you come back again. So deciding the master pattern is very similar, but because the master pattern is not that transformation in learn. So that is some of them are diamond. That is only this is the diamond statement. But most of them not they are told. And is looking, I'm not at all. These are complicated historical factors. Now let us say, if there is why so many related to that, that is the these are some of the occurrences of the these are this group of measures diamond occurs yes in this part because the water factor is not then there are occurrences in the body come to I think that in pattern we have important things visiting that. You have seen in the morning that the benefit of different colors and different time of living. This photograph is very long as well. One is outside and the other one is inside. One is silicon. These are aluminum. These are aluminum. And what we occur in Palestine. These are small systems very common from a system. These are complete and autonomous systems. Within that, there are many potential of and I have to coincide with the major scale. But it's immense the other part successfully. Both the granite and performance they have been able to set time. So this automatic consultant and then we failed. Automatic and but then I saw yesterday granite model with the base rock. We do not know the more than that. Because that's obviously reasoning. Very difficult to share the particular. So when that we have recorded in my bill, which are entered into it, are not definited and also regardless of the automatic. the contact of the side are all the options. So this is what I want to say in field. And this is the technology. Right now, which is becoming a society. The side of the is not wrong. But is not responsible for what they can. So they are which would have been formed by mathematical this is a broad geological map of Odisha, when they are the member of Geoscientists. They can measure and close to the western margin of the economy. And they were the disease and and some other there was beauty and others, but in the northern and western margin, now we find that is when many of the students were not familiar. What is this? Before 1936, the entire name was known as the Peninsula. India administrator, after they were Delhi, so in 1946, we divided this point into the categories. The black line below that and this that is the open isolation. Beginning of so that it's a non-permanent. So this is a division. Now after 1970, after entering but for the other, we consider this part, only the northern part is the southern government. And then I grabbed it up, and then this was a community. And the 100 parts, and that's all of them. And that's why I love it. There is the center very at a high repetition. This is the number map, the compared map. Anyway, there are many things written there which are I am writing written at the bottom, which I think I would have read. Camera is cover for that section, or one of the section. And then other light, and thermocline is the color. These are thermocline organizers will connect to the light of the color. And there are refined granified tiles with pink color. Refined granified tiles and there are amorphous passage by one side bodies and I think it is not coming. Yeah.
ये करें स्क्रीन थोड़ा किसी रही है उससे ना ना थोड़ा रही है ठीक रही है हाँ
Okay, now what to create the map? Rest is the underline highlights in the different. And the partial products in the different out of this meta study, I am meta project outside 116. About 40% I hear. I can say the sediment and humanity is in our. That's why when I explore and I get well and outside the camera. And there is not much of them. Because they are going on 720 kilometers. They must produce any answer. And I'm hoping I'm ready. Yes, even I more. Even I don't get another. That's why something I get out of saying like and I have the characteristic and also when men in terms of that was the problem. That was the idea. That was not so both the methodologies and the analytic men anytime anytime you get this kind of problem and I think there are better than some for you. They don't handle no problem. Okay, the delicate part. The standard of the now what does it mean? Government people get on the way. On the way in the name of short drive. I think students know who get that way on the way. That's one of them. Because some PM model. They are one drive of Odisha. Mohan. Then we have a place of Mohan. Actually, the common type, the real Roman has a connection. So, like, Mandalay is a some of these Mandalay, when the element is on, people metabolize from here, to July, after waiting, it transforms into late signal. Mind has will break down, it will produce that one will go from the person Monday to the man will come out. That man is for a direct that was remains behind. The reflector is not that the sustained artificial, or like iron. What can matter clearly? Despite matter the kind of plus benefit, and there is also any of us can tell them. And good that we can have the and if you have organized so you can have another set of things like Mohan, so many others. So that's how this fundamental starts. I can't next.
Screen brightness अधिक है ना
And this is the problem. The protection mobile. That this is divided into provinces, not necessarily for your concept. Many localities provide elements of US metabolic. That's called ultra high oxygen metabolic. So this ultra high oxygen metabolic is the next thing now. How do you know it has got that one? Because protection if you have the suffering in context with what? Just a lot of Alpine rocks are not default alpine rocks, but here are the default alpine rocks are not. They are indicated from critical exposure. That is random moment to be found. Why I am talking that? But you remember this. They are different. Damage, one market, and then what in addition to that, the president promoted I think
Points at it is more better the logale.
okay. Outside
Technical.
This is the geological number. This side is all that was called technical. There we have geological numbers. Second number is you can see from here collected everything was mostly like this, so then you come and to diagnosis and but there are some magnetic temperatures which are rich suppose protein characteristics of the just and they are also from thermobaric then all the things. Then we have thermogenic export of phosphonization from one to the then it is most important for the because they don't form the moving another. But indirectly there is something because they are not moving. So there is a lot of it. They are good sources for only different. Then there are chemicals. These are untreated chemicals. They are also and only the respect is the well. What can produce Now there are interesting bodies like amorphosite complex, alkaline complex. Is amorphosite having bodies more than right? Only one there are contact only. Without contact, there is contact. Lot of saturated coordinate, and then the oxygen complex gets out. These are some products. Those are fundamental. This is how a fundamental is an outcome. Then the light and combined interconnected sequence. This is fundamental science. You can get into the now that is the case. And government. This is only fundamental how to the extension they have to eliminate the influence in the formula, the government so the record of and out of the weather out of part of the influence. So the difficult so they have this is reported form. These are physical electrons. Tapi lagi dalam sesuatu yang berbeda. Dan juga dengan elektron, kita dah sampai di mana? Dia kan aku lagi dengan elektron dan elektron sampai proses kita. Kalau kami sudah kita belajar dari kita pada ini pandai. They can control them. Is an loyalty. So they can form negative. I have got that one. You can form something. Body level, power point, outline, and market. And you can ask him. So this current one can get on rooming. And already convinced. And the round is one, and then one. And then for example, government and the government. This type of things are government, body. Already in a government or this type of analysis, MJ is very nice. Everybody has a mental efforts. The government reported so this is the voluntary carrier. This is another. This is another. This is mind. My where is the mind? This is the great color. Iron. This is a finite object. And this white is for the first signal. This is the wind. That is the this contact is the summit assessment between the island and that is my you can say part of class according. This is some of the rupees on there. So why is the material content level This one sometimes contact with other number of internals. Then they will get it and why is similar ones and then pro system that why they combine all of that because of network. Network will get all of them. Not only about the element content.
They also have some industrial sector. But they just come
Otherwise, you have to but Ruben doesn't come. Ruben comes and he doesn't come. I'm trying to consider that that's the big train of the effect. You want to plastic. But the contact of plastic granulates, putting at home, you want to lower the Western marks. Not trying to add or this is the respect is kind of made of techniques and occupy the visual facility before a bit. Many other things. And from they can go and then black and then blue and this one this is our 9 area. So why this outline was important? But what are they done? If there is a life, because blood, if there are ability to it's a blood story. So there is most of this on the map of Odisha, that is the Indian problem. The Indian problem is the from Ramai to so in fact, there are some problems. There's an ideal development. We have to improve it. The partners and the southern part of the development was like it happens. Then another thing. This is a common this also affects the outline. Fakir, happening right is the left side, this side is the after look at the proposal, the second pattern. And in the market, that's another thing. Mobile bank starting with online credit, laptop and laptop. That's all. I think of the outline loans from different. The outline. Very good is something. So this is there was the same process, they get filled. And those are get total feedback. Like 1,000. And after closing, then nothing carried with the model, they small, different classes, and without impact with it. Like basically, that kind of thing. So this is why okay, not entirely. Thank you, sir, for the informative session. Thank you very much, but we have to cover a lot of
what are we doing? Right from the beginning, there are a lot of things from there. But what I'm going to tell you here is a part side view of it's not only that level in India. So I take you from North Africa to Kanyakumari. So what I try to say, I go with your talk, and before I will explain the location, I also tell you a little bit about the geology, which details and the other speakers have highlighted, so that you get some idea. So, next. The world of gemstone, when you say it is actually divided into two parts. One is diamond, the other one is the carbon gemstone. So the diamond is, if you see the comparatively the total money part of it, the diamond covers very huge value. You can say about $90 billion. That is the business we do in the world. And cornerstone it is paid to $12 billion. And everything in world over, it is concentrated on the exploration, mining, or trading of the diamond. Because you get the maximum money when it deals with the diamond. And you know the diamond, you get the diamond from very specialized rock, that is hematite, leptoite, or ultraviolet leptoite. Whereas when it comes to color stone, you get a multitude of geological settings, whether it is a metamorphic, or it is thermoelectric, metamorphic, or it is sedimentary. And Dr. Stiglitz said, you can also say that from the mercury to water, that is open. When the surface water circulates in a very climate zone of the sedimentary form, you get water. What is primary? As I said earlier, I said that by diamond it is when the humanoid, lateroid, or similarly for the color stone. For the other sources, the secondary source, because most of the gemstones they get released from the planetary rock and different levels, like Olympian or analytical. So the most of them you get from the Olympian or the planetary rock. I spoke about the gemstone history. India got the maximum diamonds from a place called it's a Lokonda rock, technically and that was known as Poland, where all the top and very big diamonds are collected from there. So this is how you can target for the primary as well as you target for the secondary. Already it is located, I am not going to that. The main the use of the gemstone world over is the jewelry and ornament. And other part, the astrology and other part, that is not universal, but it is pocket. Like in India, we have lot of demand for astrology stone because of our own understanding of the astrology and its science. And the main part of the entire gemstone market is a luxury item. It has no other use other than used by the kings and rich people. So if all money with the gemstones, as we have seen the phenomenon, the red color rupee which is there in the front place. Imagine that rupee, which is about 55 carat katwa, has got $34 million. So a 55 carat means it's a very small size stone which can give you that much gold. So it cost luxury item and it earns high revenue and it helps in economic and progress of the country. You can just have a quick look that in India, which actually contribute to the 29% of the global jewelry consumption, it's actually sharing world export. And right now, it's fifth position. You can see the value of it is $846 billion in the jewelry market in the world. India started this position, and the total export of the gem and jewelry sector is contributed to the 7.5% of the GDP, whereas the mining of metal minerals gives only 2.5% of the GDP. And also the total export of India, out of total export, the jewelry sector gives about 40% of GDP. You can imagine the value of gem and jewelry, and the other paradox is we don't have any mineral deposits which I come to you, yet we are this much of revenue for our country. And Raj has said that we are the largest manufacturer of cotton polish diamond, and he has already said that almost 9 diamonds out of 10 diamonds in the world are cotton polish in India, that is in the Western Indian Surat. So India ranks first in export of cotton polish diamond. The main money comes by importing rough diamond and then exporting them as cotton polish product. I already said that a diamond goes from this kimberlite, ultralight, ultralight electrophile. So it is a high pressure, high temperature mineral. The minimum that you get is something around 100 to 120 kilometers below the earth, and the temperature pressure and pressure for diamond. So this is like a cartoon where it shows that there is a graphite diamond phase boundary, below which you get diamond, above that particular line you get not get diamond. So kimberlite, which are the mainly the carrier of the diamond, they come generate from the deep and the mantle, and they carry the diamond which lies below 130 kilometers below. This is the typical kimberlite pipe where you get the diamond. So what are them? There are 3 parts of this kimberlite pipe. The top one we call it as a crater basis. In between below it is a diaphragm basis, and the last one is the narrowing down is the root zone. So maximum diamond you get either in the crater basis or in the diaphragm basis. And you see the rough type which you get in India, we don't get crater basis for the diaphragm basis and root zone. This is another microscope, how it looks at diaphragm basis part, and as well as the root zone basis part. So now coming to the distribution of what you can see, the green diamond are actually the main diamond, whereas green one is diamond, but they are generated more than 200 kilometers below the mountain. There are other type of diamond which are like alluvial, as I said, it's the secondary source. The other diamond you can see of the meteorite impact, that is more of an academic knowledge. And the diamond which falls in the meteoritic impact is called as lost granite. So when you know the diamond is a cubic form, lost granite is an hexagonal form. So that is how you already understand a pattern which is has a tail or bottom will go down to the diamond graphite base or diamond graphite below that only diamond form. So you get the kimberlite and other thing coming down below from the mountain to take off this diamond. So we can the most of the diamond which we have got from the Odisha area. And then at the end, I would like to say by Dr. Vibhuti Raj that we are the first people to know about the diamond. And these are places where the diamond is known from time over here. And still you get diamond in this area. As better as Kondo, that is where we have got the maximum event diamond. This is that part which shows that once you get a region that is the area where maximum diamond is diamond. So this is the distribution. We have 3 areas in India where we get diamond. That is the Bundelkhand Plateau area, that is Palla, Mata, like 5 feet there. Then you come down to Eastern Ghat, and the eastern part of it, that is you get in the Western Plateau. There are two places you get that is finely called Gemology, and the other place is Bhubaneswar in Odisha, Western Odisha. And the maximum diamond is found in the southern Indian area, which is known as the South Indian diamond province. So where you get the maximum occurrence of the diamond, and unfortunately most of the kimberlite you get there are the root zone. That is the small impact. Even the area of the diameter of the kimberlite pipe would be say 100 meters. So these are such a small body. In their rich in magnesium mineral, they get easily altered, and to get those kimberlite is very difficult. So you need very high-end technique to locate them. But since they are good job, no diamond is there, but commercial exploration is very difficult. All the rich diamond deposits in the world over are occurring in the kimberlite, which are much younger. Anything which is less than 200 million years and coming up to 30 million years. So the Africa, Canada, wherever you get the diamond, they are in the kimberlite, which are much younger. These are some of the diamonds which you see in the South Indian diamond project. Now coming to Parna. So Parna is what happens about the Bhubaneswar Rasan is that the Vindhyan system. So at the bottom of the Vindhyan system, there are certain conglomerated zones where you get occurrence of the diamond. The only one primary source is found there, that is Madhya Central or Himalayan Valley, where NMDC is doing mining. And the green color blocks are the area where the Geological Survey of India is doing a lot of exploration. And the one with the blue star, that is where the Pamela diamond is existed. And further to the western side, which is not shown here, the Rio Tinto has discovered a big kimberlite pipe, buried kimberlite pipe, for which the mining Aditya Birla company has taken mine for that. And you can see directly on the right hand side, the diamonds are collected from the gravel bed. So they collect from gravel bed and conglomerate, that is of the process, and send it out to diamond. This is the kimberlite NMDC mine, Pamela diamond mine. Here it is roughly. Now coming to color gemstone, as I said, it is very varied. The major the host rock is pegmatite, and other things are metamorphic and rhodopsin and very nicely explained, and they are and the last one is metamorphic. And earlier Mr. Roy, he spoke about the glass shell taking the view of the glass shell. When the hydrothermal solution reach in the emerald getting the nutrients, they form at very low temperature the emerald. That is why you get the fluid inclusion which is shown to you. Three-phase fluid inclusion is found in the emerald associated with the glass shell, and that too it is in the Bhuja area of Colombia. So the Colombian emerald deposit is having that characteristic. So anywhere you get the three-phase fluid inclusion, invariably all those people know that it is from the Colombian emerald. And as I said, that most of the major gemstones like tourmaline, opal, granite, and many other interesting like the beryl group of minerals, they are associated with pegmatite. So the understanding of pegmatite is also a very difficult subject. I will request all of you that pegmatite normally people the study of pegmatite and understanding of pegmatite, I can say with certainty in India is not evolved. People get to understand what is pegmatite because it's a coarse-grained, white-looking rock, but it is very interesting when you come down to the critical mineral, rare metal, or the mineral. So this is just to tell you the quick glance. The red color is a granitic body, and the pegmatite or the hydrothermal phase or new metallic bed which emanates from the granite, it travels along the different weak zones of the rock type. So you can see the blue one, it is written the blue zones which is not for the mineralized barren. Then coming to the pink one, which will have some mineralized and rare metal. And when you come to see the yellow one, these are highly fractionated pegmatite wells, and you get all the gemstone and the critical mineral in those phases. So pegmatite which is traveled far away from the granite will have possibility of having the more gemstone and rare metal, which motivator metals are here. The drawing example that presence of sodium will indicate some junction of it. In fact, it will indirectly see what the soil says. The more the fractionated pegmatite, more the distance they travel from the source of the canal, there is a possibility of more presence of the critical mineral. When I say critical mineral, the element having the atomic numbers which do not get crystallized in the first phase, they remain in the solution for quite some time. At the end, when they get the right opportunity, they get crystallized. So wherever you get buried, and Karan has said, the buried is color. The pure burial is motionite, which is a white color. You add chromium, it becomes color. You add iron, it becomes acromanite. You want a particular ferrous iron to the optical beryllium aluminum silicate, it becomes cellular. You add manganese, it becomes monazite. So the transition element plays a major role, and that also indicates the geological scientific. And when you look for emerald, like we are getting in the moment you say emerald, there is a chromium in it. The moment chromium, you say chromium will only come when there is an ultraviolet atmosphere. So a beryllium aluminum silicate and place chromium host for where chromium is there, the chromium joins there and create emerald. So that is how people say the morganite. That means the surrounding area is some manganese in the host. So these are the examples that we are from marine. Marine has varieties of color, and what Dr. Strickler was highlighting in the short graph where tourmaline having a copper. So that is one of that is a copper blue color of tourmaline, which is rare, known as Paraiba. That only is found in Brazil. Now it is found in the Africa. So Paraiba tourmaline is the topmost quality of the tourmaline now it is at the world market, and this is actually multicolored tourmaline. So this is also you get in the same shade being pink and other color. So that is also a very costly tourmaline. We don't get this type of color one in India. So already discussed, just to tell you that you have a granite source and the pegmatite is the red color, and then with the magic and aura of the zone, you get the depending on the situation, you get the emerald. So that is how it is given. So this is again the idea that is in the concrete you get. Pegmatite except within the multi crop, you get a zone known as rundown and feldspar, that is known as bromosite, that also has a capacity. So this is again I will not go into them. There are many technical models are given. So please go through that if you have interest. Already, Mr. Mohan is showing it, the distribution of colors to our wall. And this is interesting because India, the southern area of India, Madagascar, and the East Africa, and coming down to part of Antarctica is a zone which is known as Pan African belt, where the maximum gemstones are concentrated worldwide. In India, we go from top to bottom, that is complete sapphire, ruststone, emerald. Then we have the amethyst at the agate in the Deccan top. In Odisha, we have got the the ruby, sapphire, and also the pegmatite, and gem mineral like aquamarine and other copper, and coming down to again the ruby analyzed in the same ground. Quickly we go on. This is the sapphire you get to the place known as Pena area, district Soda. It is at the height of about 4,500 feet. But the color is very color crystals are found in the costless of the wall. This is how someone the new custom photo is there with very helmet here shared it in the geology from the Kashmir Lunar Development Corporation. So they have to go to that high area and there are some mining staff and they try to get the sapphire from there. This is I have already said about the two of them. Then coming to Rajasthan, there is a big 200 kilometers, 225 kilometers zone where you get the emerald associated with the Antarctica Africa, similar to the Odisha. So I'm not going to that, just have an idea what is going on across the world in this area. This is some detail of a particular area where the pegmatite and the Antarctica contact zone they are getting the emerald. The same thing, emerald you get the color from the Rajasthan area. And coming to already taken over the eastern part of India, all along the border area and get all these gemstones and already clear stuff. So Odisha has still lot of potential in gemstones, and because of our lack of knowledge about the granulite phase and associated pegmatite, and what he explained is very nicely, the high aluminum magnesium, the rock, the zone where the polyarite, suffering, polyarite, all of that has to be studied very properly to get more ideas about the gemstone uniform. This is shared by our Vijay Saraswati. The ruby you get in the Odisha side. That is one color. This is the transparency and the transparency of the ruby. This is our area which will be going to this phase. The rectangular block is the area where you get the emerald. That actually comes from the Jharkhand, Gurumala area of Jharkhand, coming down we come to Kalapacha, then coming down to that is Joka area, then Bhubaneswar area. This actually it is if you see the northern end of that rectangle, it's a fourth cluster. The big one is in the Jharkhand, it goes there, and the analytic activity has gone up to that. So our interpretation is the emerald is Jharkhand adds to that pink zone, that is fourth cluster, and actually it continues in the Odisha, and we have ideal situation. We need to do a lot of work, and unless you do a lot of geophysical work, you will not understand what is what. This is how it occurs. Some of the emerald you see, and this is the what we discussed taken on the third and what and start to go like again, southern India, we also explain the continent collider. We saw a town, a cartoon of town where continent collider is a big found. That part we get in the southern India, the lines, they are actually collision between the Dharma pattern and the granite bed, and almost red fibers are moving. Some of the area where the monoculture is there, and this is again shared by Dr. R.V. Kala, that right side photograph, where that kind of photograph again, that is some to the monoculture complex. This is again shared by Dr. R.V. Kala. These are the again activities you get in the Deccan Trough area, especially that and Aurangabad area you get. This is the latest find from the Nagaland area where there are the news that they got a lot of diamond. In fact, when we studied the found that these are quartz, this is known as consumer diamond, where the quartz having the both ends, the both pyramid both sides. Normally quartz will have a one end pyramid. In that it will tell that this quartz has been grown under some Qatar's ocean where it was floating and growing like a piston. So thank you very much. And this is from the Malla area. We have 57.4 carat. So that's shared by Mr. Geology Committee Bhubaneswar. So thank you very much. I hope you will get some
Thank you, sir, for enlightening on the different organizations of India in a very short time. As we are running out of time, we will move to the next lecture. May I request from the sir from World Consultants, please come on to the stage and comment on general mining and capital. Tuesdays, the time of event will be delivering, and I express my gratitude to my Fakir Institute, some of these dignitaries, the eyes, and the competitors, the mentors, and their students. Then around the past, graduated from Geology, 1995, and I am a member of first mentor of my university. Having more than 20 years of experience in multiple areas like copper, road, iron, bauxite, in many countries like Africa, Middle East, and India, and the United States. And the bedroom before our national services, it provides multiple use of services in geology, exploration, museums, geoscientific business, and so on. I just take much time for the techniques of my working experience for Kazan and Narmani. What I need to be there for 45 years in Zambia. So I just tell my leader what's the experience, basically during my demo. That is anything it is not much it is been widely spoken in time. Emerald is basically my specialized particularly in terms of emerald. Emerald is very family and different type of emerald. Big variety, and low variety. We have already spoken about this. I'm not going to take much this time on this. Emerald is which is introduces chromium, vanillin, while organizing varieties manganese and everyone in yellow it is iron, like actually is iron bits. And personally, only very colorless there is no impurities inside. So, you see this, why it is important? Emerald is giving importance in colors stones, they reserve these secrets in terms of the only survive number, the most precious gemstone in the world, like two separate parts. One is the diamond and all gemstone. But here, because of this significance and symbolizing consumption against, it is widely popular in the world and people consider regulating that emerald is more importance. And emerald occurs in different countries like Colombia, Zambia, Zimbabwe, Madagascar, Ethiopia, and many countries. Even also some of the countries I come across, I do on that one, like Pakistan, Afghanistan. In even case, just we discussed Afghanistan, Rajasthan, Odisha, and apart from this, my focus is the Zambia. Zambia is having contributing 20% of income to the world market. So only carbon mining is a definitely company that they use mining potential in Zambia is so we will discuss not much Here just simplified geology, how it is being development is on there in the exploration as well as the mining. How the mining effectively is then gets part of mining. So basically you see that is the end of country. It's surrounded by Deer Congo, Malawi, Zimbabwe, and Angola. These are the people that you can see say. And in that one, that is sided point, it is the compromised region, but the compromised region
Set pointer ଅଛି ଆଗ ସ୍କ୍ରିନ୍ ବ୍ରାଇଟର ଅଛି ତ ତେଣୁ ସେଟା ପଢିଲେ ଜଣା ପଡୁନି।
So if you see the other part of the electron, basically you can overstate the province. It is because Deer Congo to northwestern province and then the central province. It's called the Coppermine province. Those areas covered by gold, catalog province of copper and the province. In between, particularly the red point, very only the cold area is called Mikara. Rural emerald restricted area. That is the area when you carry your method, it is only 890 square of it. That is the boundary when you see something localities and how it is very similar to our science area that we discussed about it. Study of this area basically says that here the Canadian, the 5 million Australia, the pegmatite is rich in calcium, which come contact with the MOVA series, particularly the Zambian metaphysites, that metaphysites belong to the Mesopotamic area, something like 1,100 million years ago. So this Pentamathic schist rock, which is an chromium, and come compared with the English rock of Pan African origin, it is very recent when you are having your pegmatites with rich in very big comes in contact with this chromium part that is interested in getting. So this is the geology, particularly the geology of the Kapubu. They call the Kapubu area because the river Kapubu was passing through this emerald field area. So this is name also called Kapubu emerald field. You see this plot is complete. We are walking around this, particularly these points that determines of metaphysics and automatic schist rock, where you find many complete and pegmatites get included in this and finally get the emerald. So how emerald is like not very things we have discussed about this thing, very sketch, conceptual sketch. This is the surrounding rostrum. Where you find this is called magnetite, actinolite, and so that is the problem. And the middle part is the pegmatite, having vertical aluminum, and it is come across contact with the covalent. And this is all area. And that you are on like they are called reaction to. So here it is the point where switch one, the host of there, and you know there, then you get a reaction, then you find out. So I'm going to give the demonstration. And from pictures around mining, which is that is like so you get your basically you can see that otherwise called the TMS is performed usually called it and this dark multiplication you totally find the values of the pegmatites. Not certain each other rock and you can find then all emeralds in contact and reaction zone. And you find this particularly this is the mine and in cities the lot many it is also taken the structure, shear growth and all those kind of things. So these are common factors. You see this is shear how contact zones are there where you find even the million carbon production how we produce there. Then this contact zones are called BPS zone, biochemical combined mica. And if you get also
because of the hot hydrocarbon solution, and your number will be fine over there, and you get your and this is too funny because usually come also from the what to maintain range from particular and what I actually is also very important over here. And it is very simple there. It is small camera where you can things in the body. And this is the occurrence. How you can offer the schematic can be pulled that one. This is the radiography, the sequence. We get microcysts and tubolites, and this is the page, the automatic food here. And then finally, the full make. Content put into this and cross cutting the component, instrument, both kind of time to get to the end of the presentation. Exploration. Generally, you do exploration that geological mapping, traditional geological mapping, where most of partners are and fitting mapping or something of outcome. These are main part of the structure mapping. Remote sensing vehicle goes for that one area and geological streams and sampling and geophysics also making advisors of mining the emerald because the pegmatites, particularly from that zone, even all of the area, the pegmatites having radioactive minerals where it is because of the radioactivity, the radiometric survey is quite helpful finding the pegmatite and those in very PMS 40, it is a magnetic content, it is well taken to magnetic survey. So, all based on this, those tests remain required, and when you get the finding of the PMS zone, it is very important when you get your postdoc. That is important for your bacteria. And usually, when you get your interaction of the pegmatite body to the postdoc, generally there is a reaction to usually get a 0.8 to 1.6. Think about only user and this years I have seen that the point where excited is not a magnetic component while this another kind of technology is called induced spectrometry. That is the only technology where you get your radiometric for your samples. So this is basically you just take just those usually or pegmatites or on over this vacuum content where you find the environmental overweight. This is the aromatics brand, but you see high magnetic zones where you see your mining fish, then they are only mines in that area. And this mining, this is a pattern bridge. It is one of the world's largest emerald bridge and a well mechanized mine. We generally do like way. It is the pit mapping. This pit mapping already is done and how the pegmatite is mapped. And with the people, this is the surface plan. You see how pegmatite gets included into the changes body. You see here, the pink colors of the metacyst. Generally, it goes down to your epibolite and blue colors. Then you go to the light green, that is called the automatic system. So then after you get your football mica. So generally, I shown you the football mica. That is very important part. The football mica, the same is contact. You get a much more comfort. Even I think the same thing will happen in your Odisha. That's an idea. I don't know. So this is the Australia because most of the contact zone, this contact zone, they will find the structural graphs. That is very sensitive to when you get into temperance over. And we see this mine is that it's a big, very big mine. It's around 1.5 kilometers of length and around 200 meters of depth. And most of the equipment is you get your. Then after this model, then even the reaction tool, that is the reaction I told you, it is component and input and time. You model and make it a buffer. These buffer tools can calculate the total volume of black hole. These tools, that is historical statistics that if you mine, here generally, if you see here, strictness tube. In emerald mining, the strictness tube goes to 1 to 90. That means you mine 90 tons of waste material, you get a 1 ton of old material. That is the old material that is for the reaction tube. And if you get this 1 ton of old material, then you get probably 8 to 10% of which here in this case we are getting 50 to 60 grams per ton. That is the rate. So it is a historical mining process, but one day you are not getting. Sometimes that's what the people say in the explosive tests used to do the bulk sampling. Bulk sampling is the only methods that you to do something, then you get it, you get your redundantly how much grade you are finding, then you can make your project success. So that is the only big nature of the gemstone. So here, how you do mining here? It is generally you do with the block models and with statistical models. Then you go for a long-term, short-term, mid-term planning. And then you always mining. And it is a very patience business. You go mine by waste, blasting the all waste material. Probably maybe 100 meters of waste material. It takes maybe years of time. Then you go into the DMS where you find your post crop. Then that is the stage you can find your number. So generally, it is not kind of a small business. It must be required patience and focus work. So here you see the ore mining, waste mining do this not so plastic, but the ore mining and we cannot go with the general plastic. We need to go jackhammer plastic and with the systematically follow blast hole because it will not destroy it, it will not crack the ores. That way the mining. Then the second comes. The mine geologist basically detects the emerald veins, I mean the related activity veins, that is 2 million veins, and the reaction to suspected zones of reactions. Those areas has to be identified by mine geologist, and that mine geologist has to be in front of the mine geologist, I mean that high security, like surveillance camera, top shelters, top people, and expert security, local security, all to be there. Then we start to open up the area. Open, they will spray out. Then the water models come, they spray water, they clean on the area. Then it's the happy. They will have with the emeralds like this. Then they have with the emerald. Then the emerald broken blocks, even you throw after blasting, you find it there or like this, people like the right shape, that is the raw emerald look like this. Okay. So these emeralds, they mine, they put it in the box. The red box. That red box in front of it, they will seal and it will go to the sort house directly. And after this, these are called ROM. After this ROM, rest of what you see, this is the plaster material. Where this is called reaction cloth. After this washing many times, 2-3 times, finally this pot is to be taken out to the wash plant. When the wash plant, it will process the ore and washing, then again had to be. All this way, all this goes to the sort house. Sort house is in place when you get your gemologist, they will see and they sorting this thing way. Then you see some of the premium members. The real premium member is the top, look like this. And these are all kind of cameras. It is categorized, they classify them as per standards like A to K grade. And I think A to B or D something like the price to will be went to Europe and Middle East those countries because India is not able to buy those kind of things. And you look at efforts like maybe something like after E or F grade to K. Those are being sold in the market. Probably cutting after cutting body this is different way, but it is the option can say. And this is see how it is the mining process. They mine ROM, they take this one, they convert, they clean, and finally they go to market for auction. And generally, even jumping I know this is very tied to high-grade options, two tied low-grade options in the market from in Singapore or Hong Kong, different parts of the Asian markets. This is what you see. According to the US property for the state statistics database, the international color is going at compound for the top 19% for the last 5 years. And currently it stands USD 8.6 billion. And the annual gold supply market only 80% of the color gemstone market currently stand at 7.5 billion. So the huge market in the gemstone. And what I will from the general profit before I got it is the premium and emerald. Because you find maybe some tons of emerald or varying something, but only the premium grade. Premium grade means you get 1% emerald. That will contribute to whole revenue of the mine. That is with the beauty of this business. And this is what I saw. The average market value for the high-grade emerald stones like $80 to $90 for carat. But after polishing, cutting polishing, the value is very much because it is not controlled by certain criteria of polish, not like diamond. So it has the price depends as on the buyer and seller. So it is depending on this flow of the market. And you see the low grade emeralds something like 4 to 5 rupees per carat. And everybody knows the big market in Jaipur, India. They specialized expertise in cutting, polishing, with material gemstone as well as emerald. So anything, any understanding, any knowledge on that one? White emerald, why do we get it? Because it's no impurities. Emerald will never get anything we can say the emerald, which is very white beryl. Beryl is that that is without impurities. I think this is very rare. You find in nature wherever there is something connected with some impurities or several impurities. So definitely color will be there. And emerald is rarity because of the chromium technique. I chromium vanadium ion. But it's different. Is green. Pure vanadium and even vanadium yellow is greenish. And then I hope so. I think something that remember. If it is high chromium, then definitely green. Pure green and this thing. And depending on the clarity, transparency, and quality, the price, everything will be greater in some. Yeah, we in the mine because it is this mining since more than 25 to 30 years. Mining. In mine, I have worked from 2015 to 2020. That time we can record insert too. That is that means champion temple language it is called line. So something like I saw that on I call that is the size. It is something like a size. And it is option like some multi-millions. Because generally when you find emeralds, you don't find emerald with a premium variant all the way. So you find the emerald, and but if it is premium variant, you can see it is premium. Every naked eye can detect it. So the planet can detect this is premium because of the internal reflectance, it shows you some kind of brightness and something there. But even also one piece of emerald, you find something like jurisdiction. Some unique part you find a good clarity and good emerald, and some part of another kind of then the fisherman and your expert gemologist, they cut it such a way that before cutting they chisel it, they make it small from sideways, they make it separated the high grade and low all those things. So this is the business they usually. Yes. Yeah. So what do you do with this? So when people see that, it is I like to know this is the beauty of this business. You if you go to the mine, if you see all the way, even go to the surface plant mine, you mine 30 to 40 meters mica fish.
Even your emerald and pegmatites and the veins will find an intrusion in my passage, but you will not never get it. This is not my problem, this is the waste. Then you come down, you get amphibolites. That is also thickness about 30 to 40 meters thickness. So this takes now 0 to almost 80 meters is constant. In 80 meters, nothing is getting. Even you find that the same veins are included into this. Then comes your autonomic fiction. That's the things just now Jagannath told also. And our Jen all these things so it should be autonomic. When chromium, when this kind of minerals elements comes, it must have it should be a autonomic. It's a dual system. So then if the autonomic comes, it will comes because it is the amplified, then when you go to the GMS, that is important GMS. Magnetite CG. And it is not only talc, magnetite, electrolyte, limonite, chloride, all the kinds of things. There is something like a thickness of again 30 to 40 meters, but it is very structured in some with a thinking structure with the age, not many ways. So on the way, like bed like similar thickness of beddings. So this can sometimes it is 40 to 30 meters, 40 meters. So after 80, 90 meters, your host drop starts. That is called the cables. That the bed now comes. In this bed, when you find your emeralds, you find home through your veins. So veins not only transport your disbursement like this one and when I told you before. In this one, this is the mica sheet, an amphibolite, and now the contact. This is the cables with the automatic should there. When you contact with your pegmatite pass to this area, you will find the possibility of the openings, both horizontally and vertically. And this qualified this but generally this is the coast. I mean this coast means what you call the pegmatite. These pegmatites contain boron, chlorine, as well as beryllium. But chlorine is highly volatile. It escapes through any weak zones and your contact zones and your cracks, joints, and shear root. That area having your specialized the tourmaline, and with the tourmaline, you find your errors. And finally, in this contact zone, when you contact the surrounding rocks, and this will make a alteration of your contact body. This alteration is called reaction. In this reaction of the linkage, the migrate global data. That's what I showed you that one. That is the area. You see, this is the vein box, and this is the GMS. In GMS, you have a vein, and with the two lines, the terminal body developed. And this is the TMS unit, that unit, and the vein is it is component vein, for example, and it is altered. All this alteration for there, and this is the component fiber material. This is nothing but your biotech flow by mica. And this is also very good overall for animal. You find that in this area. Right. And then actually this between and you found the surrounding, even as I have walked in Congo, in copper and one. So very similar sometimes you find it, but sometimes you get moonlight and sulfurite in the mines. But it's very difficult. It is maybe transported from calcite veins, so you get it. because of the effect of because it is the frequency of light move over. This is the potential in that region. No. The time is the source. Okay. Thank you.
Thank you, Mohan, for the brief explanation on mineral mining on the bill. Very interesting, informative, and brainstorming lecture. May I request the information officer to kindly attend.
Nice.
We have a pioneer consultancy of Odisha and India. It is led by the guide of Odisha, Hyderabad, and famous of the different investigation exploration programs inside the country as well as outside the country. Today, I present you its on last year's consultancy services achievement on the secondary back on experience. Experience many users of the consultants how to identify the block, what mind, how to mind. So within 10 minutes, you can follow my video. After that, you can ask me. Please.
Right.
Thank you. With small presentation, like questions. Like, cause, angular area was there. Processing is later. Yes. Rather than knowing technology, biology, there is one need matter technology, which can become not very small diamond. That process is costly.
How long it takes to cut and polish a diamond by laser technique?
Almost one diamond takes minimum 3 days.
3 days?
Yes.
By lasers?
Yeah. Yes.
Including scanning and everything.
Now we are showing how to planting. First you plant, you select, then you plant, then you eat plants. Simply plants one food product. And now they are charging almost 10,000 rupees of cutting and polishing.
This CVD is also being cut in form by laser. CVD, lab grown.
Yes, yes, yes.
Same method.
Yes. Same method. Lab grown, that one has actually that one. Same like your test to and normal natural method. Some people like This is my program. You can like thanks from your refrigerator. When I want to let's do it. All sides.
Is there any possibility of having inclusion in CVD to make it appear like a natural?
No.
Finding really quality in civil is really hard.
Yes. But it's not the clothes and testing and heat treatment. Next. Oh, next. Come. I am taking this time and I am very you can have and there is it is one after great then you see that. That's very so it is brilliant. Thank you very much.
I'll go and tell. I the finished product. What is the project? The planning part is the field and doing everything is there, and then you are in the jungle and you are telling that gravel bed. It's very difficult in the jungle to look at that ball and that explanation. Finally, it looks very beautiful. But thank you very much for giving us that. The other one I asked spoke about type of diamond. He said type 2 diamond. So just for information, the diamonds are divided into two diamonds. One is type 1, the other one is type 2. If it is type 1, it will have some impurities of nitrogen. And the type 2 will not have any impurities of nitrogen, they are here. But if little bit boron is there, the diamond becomes blue. So current power is actually more because many times the people will be speaking type 1 diamond, type 2 diamond. When he spoke about type 2 diamond, that means it has no impurity and the quality will be very good. Okay. Thank you.
Thank you for your explanation. In the main list, Dr. Gopal, Department of Physics, School of Applied Sciences, University. And the main expertise on downstream.
Yes, good evening. And my name is the organizer, Madam Savannah, and Dr. and Dr. Actually, with whom I had a chance encounter in Bhubaneswar, Geology department. And then we keep on discussing things of heat interest, my interest, and stuff like that. And in fact, I'm actually a physicist, and but just now I talked about diamonds. And during my PhD and further, I actually use diamonds, and in fact, I break all the diamonds because I want to take material to extreme high pressure, and I think study based that now. And in fact, we have done experiments at ultra high pressure, trying to understand the physics, the middle physics of the core quantum boundary, which has consequence for the physical problems again. But currently, I'm doing more physics, but with the guidance of, I would say, because in the morning, and just before we broke to the lunch, there was a discussion that Mohan has a velocity and Alexa passion. And if I see two people actually, coming to Bhubaneswar, I find Dr. Nanda and class having both Alexa as well as passion for what they are doing. And that is something actually really remarkable because there are not many people who enjoy what they are doing. And Dr. Nanda is he dropped a fixing value having done doctor. And I think I will my daughter. But I always see each child like enthusiasm of discussing geology and things like that. So that's a great thing in shares my association. And of course, we are trying to work together, do something where our experience can be mutual. Anyway, before I begin, as you can see from the title, is applied to gems. And we have been getting a lot of gemstones, and students I'm sure are getting a lot. Maharaj had great responsibility for the lunch. We have got for the lunch. That's all the difficult and mine for the last day. That's also another difficulty. But I try to kind of give you a feeling that actually it's sort of spending your time in the next couple of days that I am going to discuss about how to use the technique which is relatively simple.
and which is non-destructive and which can give you a better information as far as testing gems are concerned, and most of the concerns that were discussed as far as characterizing gemstones and including diamonds. This is happens to be a very, very important technique that I go through and see and to remind the talk about the diamond. There is a sense of national pride when also rise. We were talking about the diamond position in the country. And the technique that I'm going to discuss is also there is a sense of national pride because this was discovered in this country by Dr. C. Raman. And in fact, he happened to be the first Asian to get a Nobel Prize. And so far, he is the only Indian to get a Nobel Prize in science. And that was pre-independence. And unfortunately, we still don't have another Nobel Prize after independence. So that's a story for a different day. And what I wanted to highlight here, coming back what we discussed before the lunch, because he had the passion and the addiction of the and he loved what he was doing. And he was a person who was great admirer of gemstones. And if you happen to go to Bangalore to the Roman Research Institute, which he established, there's a beautiful collection of diamonds, including other gemstones. So I'll take this opportunity for you all. So before I begin, so before I begin, just a brief introduction from the place where I am working. I work in Bhubaneswar, the University. For those of you who do not know, this is a relatively young university, but already it has been my place. And the campus where our lab is. So this is one.
And that is in news, no problem.
Okay. So this is the central resource thing where a lot of students. This is the campus. We have several rural campuses, and I was coming to visit sometime to find time. And coming back, I don't know if you spend much time. So I think I'm going to So as Madam was telling, geology is not just science. There is kind of an art and then sense of appreciating things and stuff like that. So there are many aspects of gemology. There is geology, mineralogy, and science and economic aspect and the connoisseur of gems are concerned. All that we can cover. Right? And I don't think we have this already discussed in So you're doing last time, but this is one of the definitions. But basically, we have the most important thing in life. And then around the outside, we have some weekends, which was just the morning meeting, not only the school, there are other communities, 4 hours, and I don't have time. But most of the characteristic part of the living by the first day, because it's a very problem. How to go from characterizing this class of gems. So, in a sense, that my job is very easy because I'm not a mineral gems person. I'm finished. But actually, I am here to learn and you got benefits, some of you. But this has been long discussed in any point of vehicles. And when you feel that is existing, as far as diagnosing them, discussed. And advanced diagnostic are kind of simple techniques, but there are advanced techniques available. But today I'm going to discuss about soil. And what it does basically is a spectroscopic technique which is the molecular technique which can provide information regarding the composition, chemical environment, the molecular bonds, structure, whether it is gaseous phase, liquid phase, or crystalline particles. There's a lot of information. But I am not also claiming that it can be carried. Here the technique has its own advantage and disadvantage. But we what else can be? And we will learn what happens here is basically this technique use a source of light, typically laser. And once you find the laser of your radio, let there be anything. As far as this problem is concerned, it's considered laser to be a gemstone. Once you shine the light, it's monochromatic whether it's light or where the light when it comes out, it comes with a modified frequency. And that modification happens because when you consider your gemstone material, there are atoms which are connected by bonds. These bonds are actually constantly vibrating because of the temperature. And these vibrations are actually acting like a basic, the information. And these vibrations in fact modify the incoming radiation and gives you the shift in the frequency that what you take. Actually, there is also a frequency that we incident upon the technical that's actually very huge, but that doesn't provide us any additional information. What controls the additional information is this omega naught, the incident frequency plus delta plus or minus. And that is why we see in the Raman. Right? To give you a very quick idea, visualize. This is the Raman spectra of carbon tetrachloride. This is something that has the Raman used. And when you see this kind of bands, when you see this kind of spectrum, what exactly you must say, you will not believe that these bands are basically telling you about the vibration of the atoms. And in this case, we have referred molecule, we are talking about the liquid, we are not talking about the solid. And here, these atoms are actually formed, these molecules are constantly vibrating, and there are several modes of vibration. Each mode is in a band. So essentially, you are able to know from this, you can find out what is the function. And not just that, this spectrum of plasma electronics are very effective to pull it down, you see many different things. This also tells you about the isotopic abundance of plasma and chlorine can also benefit carbon can also benefit. So all these things that you see, it's a combination of Cl17 carbon that is 18 like that kind of thing. So therefore you see lot of these bands. This basically tells you the isotopic distribution means it's able to in terms of the carbon. So what I'm also trying to make realize here is that if you want to get some information about the isotope, that is something this technique can actually very elaborate and also provide. I think this forum is concerned. And as far as this technique is concerned, one is particularly very significant. First of all, this is a non-destructive technique. So today we are discussing how to characterize something without disturbing the without employing a destructive technique. So the first criteria is satisfied that you don't do anything to your method. So it's a non-destructive, non-verified. Okay? And the best part of it, you require zero sample data. You need not do anything. Just take your sample, put it under the microscope, and initially it was Raman, and then after the event, people actually got Raman with microscope. Then it became micro Raman. Now it becomes very important as parallel of discussing this, but inclusive, we can actually focus on meaningful junctions rather than chemical introduction. So, and you want to do anything. So, let's do some preparation that is required. And if you compare with infrared has an option of water, because water banks are used, and that means almost. So, that problem is not there. Okay, and what you can do with very high. And another thing is the these measurement are very, very quick. If you have a diamond, we can. So since we are discussing diamond, it takes The second, to tell you whether this is diamond or not. Put it on the microscope, or just get enough back of the diamond, how well power because
Oh, sorry. Allah.
in last part, as far as studying into the significant function or change function, you don't have to take it out. You can study in the microscope. And then there is something called confocal microscopy where you can also see the matrix, the isomeric matrix, the isomeric matrix, we can only look at the into the element spiral. So this technique has a lot of potential for all these things, right? And the technique appears in very different forms. Another advantage is you can actually have this spectrometer house somewhere and they put light into a take this light and go inward. So you don't have to carry and the optical fiber can be laser that is same fiber can also collect the signal. So remote operation as far as studying the language is possible with this technique. So that is another technique. There are also and you can identify, you can identify symptoms, you can also identify the kind of treatment. If I know it's done, we are talking about medical survival right now. So, this I'll try to give the flavor from at least 4 of them. I'll try to tell you how to identify the government. I'll also try to tell you how to know if the minerals are present for some reason. And I also tell you that how to distinguish natural or synthetic. And can also provide information about the progress and genesis of the chain. Okay, but it's more to yeah.
How small is the focus?
Yeah,
Meter with the focus.
you can go to 1 mile.
1 mile.
1 mile.
And depth.
The depth. I mean,
surface depth.
There's no restriction. If it's even 1 micro depth, that is also. It's basically very like a dust.
Actually, I think when I have a crystal,
yeah,
or maybe a 1 inch size, the inclusion is in the center.
Yeah.
If you want to pinpoint the inclusion and test.
Depends if your this is transparent and
yes,
we can go, of course. So what you do is compare to focus on the surface and then we will take. Because it's transparent, the laser is going to focus on your input.
This still is visible by a microscope, we can test it.
No, there are many ways. So this is why the use is, I mean, it depends who is using it. So what I do is, I keep recording as I go. Okay? So initially I am doing let's say diamond, and then I keep moving, and then the situation where I may not get diamond, I get something else. Then I know that I am going to get something else, and that is your if you can identify that. So you can move the diamond, and while moving, you can also record at different depths. And if you are able to get something, and only one time that is transparent. Because if it is not transparent, the laser will not get it.
Laser goes.
Yeah.
So if it is going across the crystal,
yeah,
then obviously it might be passing the inclusion.
Yes.
Not stopping it.
No, yeah, so your focus is on the inclusion. So your focus is on the inclusion. Yeah. So basically, so your lens is a focal point. And if you remove the sample, because focal point is very, so basically you have something different there. So that if your focus is different way, and the light of the camera is coming back, the same lens is focus is also connected. So that is how you get information from provided the sample is transparent. If it is not transparent, it's not good. So that's the same. Right? So I'll kind of think about what you see and more. Let's see. So first question is how to identify and these mineral plants have different characteristics strong bands. And what are the different further? We have silicates, fibrosilicates, and also silicates, phosphate, sulfate, and phosphate. And now there is a database. So what is it? There is a database called rough. Okay, you can go and you can get a diagram of Raman, infrared, exactly. Okay, so this database very rich and every day there are participants. So there is a concept, and this is the typical problems. And as I told you, one carbon data product, that was the molecule. That's all. Because now it is as far as very group is concerned, then I have trees and I saw trees, completely moving in a very different ways. And these are frequency of high substantial. So these are basically where this is supposed to be happening, but this is basically different ways. Like a technology, one is very one is compression. So different kind of frequencies. So then the first thing and the easiest thing is that you can have technology and then you try to balance. Well, this method, that's the simplest thing that you can provide it. That is something online. Right? That's everything online. Right? And I think it's a lot of discussion in the morning about the very group. And this is the Roman data of very group the very land. Not able to okay, so basically this bottom one is the round shape, and this is done in some later wavelength. Later I tell you what is importance of lasers, because just because that are Raman spectrometer doesn't guarantee that you get a spectrum for everything. Sometimes you can change the excitation. So because some metals need to use fluorescence for a specific excitation level. So then you have to change it. So the information that you need somewhere there, that is basically mentioned what is the wavelength. So then if you need that, of course you get it. Right? Okay. Now, you basically compare. So first example is the natural chain that we have been discussing. First you have diamond, then you have zirconia, then you have function diamond. For later it might have one of them might have sand, but when you try to come to Mylar, or go to a spectrum Raman spectroscopy, then second, then you balance. Diamond or not. Yes. I mean, by who it is really, not a person who has no exposure to optics. Yes. Right. So, I mean, this is the simplest thing, and there are a lot of things like if it is natural and all those things that can be actually right? And just by comparing diamond to get a band, we get other brand compounds, but that is typical characteristics. But not getting characteristics is not diamond first. Right? Okay. Now, similarly, we have been discussing about real gems like the polymer glass, and emerald. And again, compared to the database, there is no actually what is part, right? So this is whether it is emerald or something that is completely changed just like database. And here I want to pause for a while. I want to discuss something that was also discussed in the beginning of this lecture. Beauty of this number technique can also act as a luminescence spectrum. So we can also collect photoluminescence at no extra cost. You are not even buying anything extra. The same spectrometer which was collecting Raman can also use it to collect the luminescence. Same spectrometer. And it's not like that the spectrometer which you know what it is for Raman. I am so you may luminescence. So that is the beauty. Of course, with some limitation there.
But then you see, because we have discussed about the difference. So this is actually a colored silica glass, and this one is actually colored. And then here you see the 725 band, and then these two, the 60 and 64, something like that. They are the spectral feature, which tells you that this is the actually very and if it just a glass, the typical broad band, which is there, and that without those features, you know that this is nothing to do with very. So that becomes something evidence problems, right? So this is the photoluminescence spectrum. So I'll just dive in for maybe 3-4 minutes because the same Raman spectrometer which you are using for looking Raman spectrometry, you can also use it for doing luminescence measurement. So how is this helpful? So as far as diamond is concerned, the clearly actually more important than the Raman. Since we have to discuss about the secret diamond, etc. So if you can record there, you can see the different effects. And you can also do it at a very low temperature. It also will tell you whether the substance is dense or on. So those things that you can get. So you get 2 spectrometers for the price of 1. So that's the comparison we have. Right? So that's the beauty of the technique. And this is just the motivation. So since just now we discussed about the type of diamond, task telling. So the top one is actually considered type 2A diamond, and the bottom one actually tilted high pressure high pressure treatment. And then you see that the big process, the luminescence that you see. If you see the luminescence, then it becomes very clear the something tilted in high pressure and high pressure. So here, the same number spectrometer, but we are not doing Raman. Of course, you see the round bands on here, this are, but it just happens to get there. But apart from that, you clearly see the luminescence that tells you that the diamonds are actually fitted on the. Similarly, we are also talking about the minerals and other red colored materials. So because of chromium, so here you see before the heat treatment and after the heat treatment, how the spectrum also changes. So that is something. This is again the photoluminescence that you can compare and find out whether it is changed or not. So that is something. Again, this is not because we are using something. But I must clarify that we are not doing proper now. I mean, you could say does that luminescence, right? So as again identifying rare gems, the garnet and similar. So we can collecting and matching and finding the result. Again, compare the 2 months, the same technique, and there's a lot of immediate. As far as different is concerned, I understand when I was preparing for there is some acceptable things that actually really configure other things which are not allowed. And people do everything, so one has to be careful what is what. And to identify that, of course, we have many different diamonds are here, diamonds, they are all then one could have detail, one could have developing parts which are filled to be sometimes which are simply filled with some organic material. Just to give you that they are, I mean, nothing has happened. So that can be very quickly figured out by checking the peak position, the luminescence, as well as the width of the peak. All of them are important. So, for example, I told you here. Okay. So this is something where the environment field by different pillars. And then you see the paraffin oil has its own normal spectra. The Johnson baby oil has its own normal spectra, and this is some Canada oil. So if you are actually seeing these things on your gemstone, then you know actually it's going to fill with this. I will have to distinct between marking or not, but you can figure out if it is color. Similarly, if you have paraffin oil or pillar, you see there, it shows those broad marks. So that way you identify
If you have an organic filter, the organic filter will allow the backbone and that helps us to come. So you find out whether this is there, and it turns out that these things are allowed. But you get to know whether it is in your and yeah. And of course, there is something called opticon, there is something called gamma share. So those things are filter, but when you enter a download, you clearly see the spectrum and you know it is there. And then very good stuff, right? And it is not just organic material, so there are plants. People are actually doing and know a lot of things like many other things. There should be more discussion that is something that can also find out if it is plants. You start to know what things find out what is 1300 and stuff like that. So that becomes very, very clear. And if you remember the first of the discussion of mapping, you can map because that mapping means you let's say you are looking for an health, you identify what is the highest. Basically, you only look for that everywhere you are. Wherever you do not get, it is not there. And you might get something else, then you will verify what is there. So this is called mapping. So you just map the boundary and then figure out which area it actually fits. So in this case, from the value you can exactly where it is that has been filled. So that is one possibility that can also be explored. This can be time because you have to do point by point mapping, depending on what area is. And then in the industry, I was getting that a lot of gas treatment. So like they put minerals like diet, they put B, etc. And that can be very well figured out whether it exists or doesn't exist. So last mineral, right? Similarly, if in the synthetic simulars, okay, where you have similar things, that can be figured out. That is also possible. For example, if there is a lot of alkali content in emerald, what you do is you will see there is no alkali. There are things that will see towards the particular site. If the alkali content is high, then it is going to expand as well as the peak to also boost it. So that is also signature that some kind of similarity. That is also present. Having done something specific, and it also depends what kind of stimuli, whether it is hydrothermal dependent or whether it is actually grown synthetically grown. That also has to challenge position after with of the beach. And this is particularly when you can see for me, because there is a variety where I thought this channel where there are water molecules. So when we do a Raman, we see very nice OH testing because the water molecule has this kind of thing and finally it forms. And there is something called OH testing. And this appears in Raman spectra very nice. Now, depending on how it is actually attached, this water molecule, you get this type 1 or type 2. Kind of what is being done. This is what you see. You start looking for the data for 600. Then we see whether this is one whether it is in alpha or it's in the hydrogen binding. Then we make it like understand only one. So you get to know because those details can be also so you then find out what is the other content in your experience. So that is one. Coming back to the last thing, that is about the genesis and the provenance. This is something actually a lot of more data is required, but it is also providing some kind of a direction to kind of provide you some input where to be the provenance and the genesis to be. This slide was also used so in the morning to remember. And here, this is from Jamia again. So here, Madam was telling that CO2 inclusion in this fluid inclusion, and then it's and this is emerald, and then this CO2. So this picture was also used from an isotopic so again, you can tell what is the inclusion and what kind of fluid And from that, we can actually provide you some lead towards the analysis and provenance. This is one of the very. And you can also find out if there is a weekend and travel CS frequency that you can find out. You also see CO2, and if you see the CS or CO2, that also again provide you some info about its analysis. I am not an expert, but how that will give you some clue where, because the morning I saw it depend price depend from where it's coming. So that also information to kind of time from this. And then looking at the Influence can be studied, so you can answer whether it's natural or apparent sentence. That we can do. And basically, we look for the CO2 normally, and if it's there, so you have the CO2. This is again expected to be very. It can provide some information. Okay? And then we look for the water peak, whether it is type 1, type 2, and that will provide you whether it is low alkaline, high alkaline, what is the good rock, whether it is very bad and whether it is intervention. So all those things are actually figured out. And in fact, I would say this morning that another now reported that then synthetic one specifically from Afghanistan, so they are just by looking at the mechanism, the photoluminescence. So then some information about the genesis, right? So conclude and some perspectives. I would say this is an essential tool for everybody working with genetics. And I'm also not telling you the only things I want to add was, but it has to work in tandem with other techniques. All techniques and this technique will be becoming more and more powerful. If you have more data, so that means you gain a very strong database. So more data we have, more experience, and then we have more intelligence. And as far as the PM is concerned, that is the luminescence is concerned, which comes actually to biospectrum, like that. So that will also be used not only to treat treatments, it can also take the other colored one, including the organic ones like polymer. So with this, so this is normal spectrometer that we have in by lab, and as well as the capability of this instrument is concerned, we have based on 4 different layers, and I probably keep this part because sometimes may not carry the spectrum with one layer, so we need to change it because process will pass along. So we have 4 different layers, including UV one. UV is very important actor. In fact, there was that so that use our system and we will rotate things out to the luminescence and we find out what kind of time there is. So this document can do more or less everything, and the one that you see, it can actually go up to 6 million. So we can collect our spectrum from 77 Kelvin, that is minus 196, then we get up to 1500 degrees. And I have also got minus pattern anti-sales, which are also looked at the delta for that and understanding of the metals. Because it's probably observing what we have in the standard. So you don't get too complicated. But you not all technique if it is metal, Mathematics actually observe problems and very hard. I did not discuss the physics of technique. This Roman process is actually a big process. Because we have Roman got Nobel Prize, actually it was got very quickly. Because when these guys is very good player, he used simple sunlight, filter it, made it monochromatic, and it is like if you throw 1 million photos, only one of them will come Roman hand, and you have to find out that one million. That is what he found with simple, technique. And these days we have access to everything, and we have not done anything right. So, the process is very big because the intensity is so high. Now we are actually setting more and more models to the number. That's why it is but it is better. Then what happens is there is some skill level. So most of it actually gets absorbed on the surface. So that's the problem. But then there's something called then it is not the same. You have to see what is the difference. You have to do a lot of modeling, find out. But that is not what we do for real world. We do for college mathematics. This will involve the means. Yeah.
Application is going on increasing.
Yes.
Because we have to throw away all of the instruments. This is what's happening. So some of the things you are doing.
As far as gemology is concerned, now it is quite versatile in addressing a lot of issues. This is now applicable in biology and molecular detection. There is a technique of surface and compound where you can detect extreme small concentration molecules, including biomolecules. So the technique has a lot of power. And if you are aware, there are particles called two-dimensional materials, like graphene, like transition from dipole to the opposite material now in physics community, and which is probably going to come in electronics. So Roman happens to be one of the best technique, the simplest, the best and quickest technique to calculate all the layered methods and graphene, TNT, and all other layered materials. So, in fact, I'm not normal this technique one day will be used so frequently for characterizing so many materials which are potentially
Especially in pharmaceutical industry.
In pharmaceutical industry, see, if you sometimes if you want to give a tablet to the kid, you say you break it to two and you have because of the power and spider mechanism, you want solid shooting. You have to be very, very careful. So what the pharmaceutical industry is a good company, when they do it in this, software, they have to draw the uniform district. So it is not a good company. You might break, you might have given the exact time not nothing. So how you can check? So they look for this molecule and then when they prepare these pellets, they will see the distribution. And this takes approximately 2-3 days. And now the whole process, let's say when they are preparing, how many drops actually distributed in the pellet. So pharma industry actually is paying a lot of money to this. So when they come to sell the product, they always don't know what the students are. They have a lot of money. So we can down there and right. That's right. Yeah.
The capture time.
It depends on sample. Transparent sample, you can get in 1 second.
Upon results.
And then, as soon as the sample, this is say 1 second you can record. Okay, so because we have very hard to make this. We can compare. And you can directly take your suppose where you can read, directly put your name there and then collect, note down the separately. So it's possible. So in this side, like, no, I am not doing any answer.
Yeah, and it was brilliant. And in fact, actually, in my PhD, I have proper spectrometer, which I used for my PhD. Yeah, and one can have commercial cost. So for us, normally not just a technique characterized. This technique was we not development.
you.